Hello to everyone. Before we start coding, let's first understand what GraphQL actually is and why it's become such a popular tool in modern web development. GraphQL is a query language for APIs. API stands for Application Programming Interface, and a runtime for executing those queries against your data. It was developed by Facebook back in 2012 and open sourced in 2015. Since then, it's been adopted by companies like GitHub, Shopify, Twitter, and many more, and for good reason. At its core, GraphQL allows clients, like your front-end Angular app, to ask for exactly the data they need. Nothing more, nothing less. Let's say you're building a UI that needs a user's name and email. With GraphQL, you can write a query that only requests those fields, even if the backend has dozens of other fields for that user. This is a big shift compared to traditional REST APIs, where each endpoint usually returns a fixed structure of data. With REST, you might either overfetch, getting more data than you need, or underfetch, needing to make multiple requests to get all the data you want. GraphQL solves this by giving the front end more control. You define the structure of the response right in the query. That makes apps faster, more flexible, and often easier to maintain. Another powerful feature of GraphQL is that it uses a strongly typed schema. This means the entire API is described in a single place, and tools like autocomplete and validation become possible, even before sending a request. And because of this schema, tools like GraphQL Playground or GraphiQL make it super easy to explore your API interactively, test queries, and understand how everything fits together. Now that we understand what GraphQL is, it's natural to ask, how is it different from REST? REST APIs have been around for a long time. They've been the standard way of building APIs for over a decade, and they work well. But they do have some limitations, especially when building complex front-end applications. Let's break down some key differences between REST and GraphQL. Data fetching. In REST, data is accessed through multiple endpoints. For example, you might have /users for a list of users, /users/one for a single user, /users/one/posts for that user's posts. Each endpoint returns a fixed set of data, and you may need to call several endpoints to build a complete view in your UI. In contrast, GraphQL has a single endpoint, and you send it a query that specifies exactly the data you want. Whether you want just the user's name or the user with their posts and comments, it all comes from that one endpoint. Second difference: overfetching and underfetching. With REST, it's common to either overfetch, get more data than needed, like getting full user details when you only need their name, or underfetch, not getting enough data, so you have to make another request. GraphQL fixes this by letting the client shape the response. You fetch exactly what you need in a single request. Third, versioning. REST APIs often use versions like /API/v1/users. When you change the API structure, you might need to release a new version, which can get messy over time. GraphQL APIs don't need versioning in the same way. Since the client defines what it wants and the schema evolves gradually, you can often add new fields without breaking anything. And last for now, tooling and introspection. GraphQL has built-in introspection, which means you can explore the API, get suggestions, and see exactly what's available, all from the schema. Tools like GraphQL Playground make this really powerful for both development and debugging. Let's start now with the most basic operation, reading data. In REST, if we want to fetch a user and their posts, we usually need to make multiple HTTP requests. For example, one request to /users/one and another to /users/one/posts. Each request returns a predefined structure and often includes more data than we actually need. With GraphQL, we can request everything in one query, and more importantly, we decide exactly which fields we want. As you can see here, the query fetches the user's name and a list of their posts with only the title field. One request, tailored response. This means less data transferred, fewer requests, and more control on the front end. Now let's talk about creating new data, in this case, a new post. With REST, we use a post request to slash posts and pass the post data in the request body, typically as JSON. It works, but the response might be generic, or sometimes you need another call to fetch related data like the user's info. With GraphQL, we use a mutation instead of a query. We provide the data we want to create, and just like with queries, we can specify what the response should include. Here, we not only create the post, but also ask for its ID, title, and the name of the user who created it, all in one round trip. It's clean, efficient, and flexible. Update operation works similarly to create. Finally, the delete operation. In REST, we use the HTTP delete method and hit a specific endpoint like /posts/10 to remove the post with ID 10. GraphQL handles deletes with a mutation as well. We pass the ID of the post we want to delete, and again, we can define what the response should return. For example, a confirmation message or a status flag. This makes GraphQL's delete operation both declarative and informative, with no need for additional follow-up requests. In this video, we're going to install the Node.js runtime, which will need to work with the Angular framework. If you already have Node installed on your computer, feel free to skip this video. I'll show you two ways to install Node.js. The first one is using the official installer from the Node website. Just open your browser, type Node, and click the first link. It should take you to nodejs.org. Once you're on the site, you'll see options to download different versions of Node. This part is important because using an outdated or even too new version might cause compatibility issues with specific Angular versions. Let me quickly show you the compatibility table on the Angular documentation at Angular Dev. As you can see, for the latest version, 19.2, the recommended Node version is 18.19.1 or higher. Now let's go back to nodejs.org. The version selected by default is 22.14.0, which is the LTS version. LTS stands for long-term support. I always recommend downloading the LTS version because it gets regular updates and long-term maintenance. Next, you'll be asked to choose your platform. I'll leave it on Windows, and then you can choose a package manager. Personally, I use NPM, although Yarn can sometimes be faster when downloading dependencies. Once you've selected your options, you can install Node using PowerShell, or Bash if you're on Mac OS or Linux. But for Windows users, there's an easier way. Just scroll down and click to download the dedicated installer, which I highly recommend. Just make sure not to uncheck the option that adds Node and npm to your system environment variables. That's very important. On screen, I'm showing you the paths that usually need to be in your environment variables. The second method of installing Node.js is by using nvm, the Node Version Manager. Just type nvm Windows into your browser if you're using Windows, and click the first GitHub link. Scroll down a bit until you see the Download Now section. Click it, and you'll be taken to a list of NVM versions. From personal experience, I've had some issues with the latest versions. They sometimes fail to download Node properly, so I recommend using version 1.1.12. Click the version number, scroll down, and download the file called nvm-setup. Then, go through the setup process like a regular installer. For macOS and Linux users, just search for nvm and click the first GitHub link. The installation instructions there will guide you through the process, step by step. Once nvm is installed, open your terminal, either CMD or PowerShell, run as administrator, and we'll install and use Node from there. If everything went well, nvm should now be added to your system variables, and you should be able to use the nvm command. To install Node, just type nvm install 22.0.0. Once it finishes downloading, activate it by typing nvm use 22.0.0. And if you have multiple versions installed, you can check which one is currently active by typing nvm current. Angular CLI stands for Command Line Interface for Angular. It's a powerful tool that helps you create, develop, and maintain Angular applications directly from your terminal or command prompt. With just a few simple commands, Angular CLI can create a new Angular project, generate components, services, modules, and more. Run a local development server with live reloading. Instead of spending time setting up project structure, build tools, or Webpack configurations, Angular CLI does all of that for you, automatically. Now we're going to install Angular CLI locally. If you already have Angular CLI installed, you can skip this step, or remove the old version using the command shown in the terminal. npm uninstall-g at angular-cli. In my case, Angular CLI isn't installed yet, so I'll slightly modify the command. I'll change uninstall to install, and I'll also specify the version of the package. In this course, I'll be using Angular CLI version 19.2.7. You're free to use a newer version if one is available. Just keep in mind that some minor differences in the Angular framework may appear. However, that shouldn't cause any major issues. After installing the specified version, you should be able to use commands that start with ng. But make sure you applied the fix from the previous lesson, the one about script execution in PowerShell. As an example, let's run ng version. This will show the currently installed version of Angular CLI, and also confirm that everything is working correctly. In this video, we're going to create a new Angular project. To do that, we'll use the ng new command. I'll be using the PowerShell terminal for this. Just make sure you're in the folder where you want your project directory to be created. Right now, I'm on drive D. In the folder Course GraphQL, we type ng new followed by the name of our project. In my case, I'll also add the no standalone flag, because starting from Angular 17, projects are generated using the standalone component architecture by default, which means they don't rely on modules. However, most real-world projects, especially those using Angular versions below 17, still use the module-based approach. That's why I'm disabling the standalone mode here. But if you prefer to use standalone components, that's totally fine too. The main difference is how you import dependencies into your components and services. After running the command, we're asked which style sheet format we want to use. I'll go with SCSS. Then we're prompted to choose whether we want to enable server-side rendering in this project. I'll type N for no. Just a quick side note. If you do want to use SSR in your Angular app, there's absolutely nothing stopping you. The way we write our GraphQL queries in this course won't conflict with SSR in any way. Once we hit enter, the project initialization begins. Depending on your internet connection, this may take a few minutes because Angular needs to download quite a few packages. And finally, once the setup is done, we'll get a confirmation message saying that all packages were installed successfully and that a Git repository has been initialized. I'm currently in the root folder of the project, working inside the WebStorm editor. The main place where we'll be writing and managing our code is located in the sr/app folder. This is where we'll spend most of our time throughout the course. Inside that folder, we can already see our only component so far, the app component, as well as the main module of our application, which is the app module. If we open the app.component.html file, we'll see a basic template for the main view of our app. This template was generated automatically when we created the project. Let's try running the app to see what it currently looks like. To do that, let's take a quick look at the package.json file. Under the script section, we'll find a list of useful commands that can help us manage and run the project. The most important one for us right now is the start script. This one is responsible for launching the application. In WebStorm, I have a dedicated npm tab, which makes it easy to run these scripts directly from the interface. However, this tab is not available in Visual Studio Code, so I'll show you how to run the project using the terminal instead. Let's open the Terminal tab. In Visual Studio Code, you can find it in the top menu bar under Terminal with option New Terminal. Now we have a couple of options. We can either use the Angular CLI command, ngserve, which will launch our project, or we can run the script from package.json, which under the hood does the exact same thing. To run that script, just type npm run start. Make sure your editor is opened in the root folder of your Angular project, otherwise the script or ngserve may not work properly. By default, Angular apps are served on port 4200, so once the app starts, you can open your browser and go to localhost 4200. As you can see, everything works just fine. And to stop the application, simply press the keyboard shortcut, Ctrl+C, in the terminal where you launched the application. To work with GraphQL, we'll need a backend, a server that can handle GraphQL queries and mutations. For that, we'll use a ready-made tool called JSON GraphQL Server. This is a lightweight NPM package that allows you to quickly spin up a GraphQL server using just a simple .js file as a database. You define your data structure in that file, and immediately you get a working GraphQL API that supports queries, mutations, filtering, and even pagination. It's fast, simple, and ideal for prototyping or learning GraphQL, especially on the front-end side. But keep in mind, this tool does have limitations. For example, it doesn't support GraphQL subscriptions, so if you need real-time updates like WebSocket-based data, this won't be enough. It's also not meant for production use. It's mainly a mock server. That being said, it's still super useful in real-world projects, especially during development. Let's say you're working on the front end, and your teammate is still building the actual backend. With JSON GraphQL Server, you don't have to wait. You can mock the structure, simulate responses, and build your Angular app as if the backend already existed. It's a great tool for decoupling front-end and back-end workflows, and we'll use it throughout the course to focus on what matters, learning how to use GraphQL in Angular. On the npmjs.com page of the project, if we scroll down to the usage section, we can see an example of how the .js file, which acts as our mock database, can be structured. Right below that, there's also a description of how to start the server using the created .js file. We even have the option to specify the port and host on which the server should run. Let's scroll further down to the install section. Here we'll find the command that we'll use in the terminal inside our code editor in just a moment. I've pasted the previously copied command into the terminal and pressed enter to install the package. The -d flag in this command means the package will be installed as a dev dependency. In other words, it won't be included in the final production build of the application. Now we can move to the package.json file and go to the scripts section. Here, we'll add a new script called start GraphQL to make it easier to run our server in the future. For this script, we'll use the JSON GraphQL server command and pass the name of our database file. Let's say db.js. We'll also specify the port as 8080 and set the host to point to localhost. Now we can go ahead and create the db.js file. Since we didn't specify any folder in the script path, just the file name, we'll create it in the root folder of our project. Inside this file, I'll paste a predefined data structure, which I'll also share in the downloadable files below this video. Once that's done, anyone who wants to start the server can simply run the following command in the terminal: npm run start GraphQL. When we run our mock GraphQL server using JSON-GraphQL-server, we also get access to a built-in tool called GraphiQL. GraphiQL is a simple in-browser IDE, a tool that lets you interact with your GraphQL API. It allows you to write, test, and run GraphQL queries and mutations without needing to build a front end or use Postman or any other external tool. You just need to open your browser and go to the address where the server is running. We specified that in script called start GraphQL. When you open that page, you'll see a clean interface with two main areas. On the left, a text editor where you can write your GraphQL queries. On the right, the response area, where you'll see the results of your queries in real time. There's also auto-suggestion, which is super helpful. As you type, GraphiQL shows you all available fields and types based on your schema. Another great thing is the Docs tab on the left side. If you click it, you'll see the full API documentation automatically generated from your mock database. You can browse through all available types, queries, and mutations, which makes it really easy to explore and understand your API. JSON GraphQL server automatically generates a full GraphQL schema based on the structure of your .js data file. That means you don't need to define your types manually. You don't need to implement a real backend. Normally, if you were building a GraphQL server in Node.js, Java, Python, or any other environment, you'd have to manually define all types, relationships, resolvers, and schema definitions. But with JSON GraphQL server, as long as your data file is structured properly, you instantly get a working API that you can query, mutate, and test inside GraphQL. Let's now take a closer look at one of its most powerful features, the Explorer tab. On the left side of the window, there's a tab called GraphQL Explorer. The Explorer lets you build GraphQL queries without writing any code manually. You don't need to memorize field names or type syntax. Instead, you can click through radio buttons and build the query visually. In the Explorer panel, you can see several types of queries already available to you. For example, post. This query lets you fetch a single post by its ID. That's why you see ID marked with an asterisk. It's a required argument. You can then select which fields to return: ID, title, views. Another query option is _all_posts_meta. This query provides metadata about the posts collection. You can add filters, pagination, page per page, get the count of all posts. This can be super useful when building UI components like pagination controls. We also have all posts. It allows you to fetch a list of posts, optionally with filters, sorting, pagination, and you choose which fields you want in the response: ID, title, or views. Let's try to query count of all posts and its data. As we can see, we have 4 posts in total, and that's true because we have 4 posts in our db.js file. Below our query options, we can add new query or new mutation. If we choose mutation and add a new one, we can, for example, create a new post, specifying title and views. ID will be generated automatically. Now we're going to install the PrimeNG library. PrimeNG will be very helpful because it provides ready-to-use UI components that we can use directly in our project. For example, it includes a fully styled data table out of the box, so we won't need to worry about writing custom CSS. This allows us to focus on working with GraphQL, rather than spending extra time on styling our UI elements. On the official website, primeng.org, under the installation section, you can find the full setup instructions. In the top right corner of the page, you'll notice the currently selected version. In our case, it's version 19. Keep in mind that in the future, newer versions may be released, and the instructions could look slightly different. Similarly, if you're using an older version, the installation process might vary a bit. To install the necessary packages, we'll definitely need to run this command: npm install PrimeNG at PrimeNG/themes. In addition to installing the packages, we also need to add the proper providers in the app.module.ts file. However, if you are using standalone components, this setup should be done in the app.config.ts file, where the main application configuration is defined, typically inside a variable named appconfig. Now, while in the terminal inside my code editor, I run the command we copied earlier, that is, npm install. Once all the necessary packages have been installed, we should be able to import the required dependencies into the providers array. Next, I open the app.module.ts file and paste the code snippet into the providers array. This is the same code we saw earlier on the PrimeNG installation page. Of course, we'll need to import the specific dependencies used in that code. When I place my cursor on the missing symbols and press the shortcut Alt+Enter, the editor suggests automatic imports for those dependencies. However, for the predefined Aura theme, there's no automatic suggestion, so I'll have to write the import manually. And that is import Aura from @primeng/themes/Aura. Now, back in the documentation, we can check whether PrimeNG was installed correctly by simply using the p-button component. I'll copy the example code provided on the website and switch over to the code editor. Inside the editor, I open the app.component.html file and remove all of its current content using the shortcut Ctrl+A to select everything, and then delete. Next, I paste in the code I copied from the PrimeNG site. As we can see, we get an error. This is because we're missing the necessary import in our module, or in the component itself if we're using standalone components. Just like before, I can use the shortcut Alt and Enter to quickly import the missing element. Let's go to app.module.ts. Here, in the imports array, we can now see the new entry that was just added. Now, back in our application, and don't forget to start it with the command npm run start, we can see that the button is displaying correctly. One final note: if your browser is set to use dark mode by default, the page may adjust accordingly. That's because PrimeNG and its components support dark mode out of the box, so things may look a little different depending on your system settings. The last thing we need to do in setup step is to create environment files, which will be used to store important constant values like the URL of our API. To create these files, I open the terminal and run the following command: ng generate environments. We're able to use ng commands like this because we've already installed Angular CLI earlier in the course. After running the command, two new files should appear inside the sr/environments folder: environment.ts, environment.development.ts. These two files serve different purposes. The file ending in .development.ts is used during development, while we're actively working on the app. The basic environment.ts file is used after the app is built. For example, when we deploy it to production. Let's first open environment.development.ts. Here, we'll add a new key value pair to the exported object. Let's call the key API URL, and for the value, we'll insert the address of our GraphQL server. A quick side note: in many GraphQL setups, the URL might include a /GraphQL suffix, like this, but that depends on how the server is implemented. In our case, with the JSON GraphQL server library, we just use the port. No extra path is needed. Once that's done, I'll copy the same API URL variable over to the environment.ts file. Normally, this file would contain the production URL, but since we don't have one at the moment, we'll just leave it with the same development address for now. In this lecture, we're going to talk about the GraphQL schema. A GraphQL schema is a contract between the front end and the back end. It defines what data is available, how it's structured, and how clients can access it. The schema tells us what types of data exist, like post, user, comment, what queries we can run to read data, what mutations we can use to change data. Let's look at a simple example. Here's a post type defined in a schema. This means every post object has an ID, which is required, a title, which is also required, and an optional number of views. Next, we define how we can access these posts. That's done through the query type. This tells us we can fetch all posts using all posts, or fetch a single post by its ID using post. We can also define mutations like this. This mutation lets us create a new post by passing in a title and optionally a number of views. Now, what's really powerful about the schema is that it enables autocomplete and suggestions in tools like GraphiQL, validation of queries before they're even sent to the server, and it acts as documentation for other developers. In tools like JSON GraphQL Server, this schema is generated automatically based on your mock data. But in real production apps, we define it manually using something like Apollo Server or other backend tools. Let's simplify some things. In GraphQL, a type describes the shape of your data, what fields it has, and what kind of values those fields hold. Let's look at an example. This defines a user type with 3 fields: ID, a required unique identifier; name, a required string; age, an optional integer. You can think of this like a blueprint or a class in OOP. It defines what a user should look like. There are also basic types called scalars, like string, int, boolean, float, ID. And you can create your own custom types to represent things like post, comment, or product. A query in GraphQL is how the client asks the server for data. This query is asking, give me the user with ID equal to 1, but only return their name and age. The server will look into the data and return just that, no extra fields. Queries are great because they give full control to the client. You get exactly what you ask for. No more, no less. If queries are for reading data, mutations are for changing it. You use mutations to create new records, update existing ones, delete data. Here's a simple example. This sends a request to create a new user and asks the server to return their ID and name after it's done. Mutations work like queries, but they change something. They're the write operations in GraphQL. In this video, we're going to make our first GraphQL query from an Angular component. But first, let's create a new component where we'll be working. I open the terminal and use the Angular CLI command. ng generate component views/posts-table, or using the shorthand version, ng-gc views/posts-table. This will generate a new component in the views folder called posts table. In the upcoming videos, we'll use this component to display a table of posts, but for now, let's focus on making our first query. Let's open the posts-table.component.ts file. At the top of the component class, I'm going to define a regular JavaScript variable called query. Its value will be a GraphQL query string. The actual query will send to the server. To make a multi-line string, I'm using backticks, which are located to the left of the number 1 on your keyboard. We can name the query whatever we like, or even leave the name out completely. In this case, I'm using the name myQuery. This query asks the server to return all posts and only include the ID, title, and views fields. Even better option for creating this type of queries is to use GraphQL tool, which we used before. It's much faster than writing it yourself. With our query ready, we can move on and implement the onIt interface in our component. we'll use the ng onInit lifecycle hook to fetch all posts when the component loads. But before that, we need to inject a required dependency into the constructor, and that is the HTTP client, which in the Angular framework is used for making HTTP requests. It's the default way of communicating with a server in Angular. Now, we'll create a new method in our component class called getPosts. Inside this method, I'll create a variable called body, which will hold an object with a query key. Its value will be the query variable we created earlier. Of course, we could also write the query directly here, but keeping it in a separate variable makes the code look cleaner. This method will return a call to HTTP method post, and for now, we'll just type it as any. The first argument will be the URL of our backend, and for that, we'll use the variable from environment file. We created it earlier in the environment.development.ts and environment.ts files. The second argument is simply the body variable, since this is a post request. Now, inside ng onInit, I'll use the getPosts method and subscribe to it, because it returns an observable object. Under the hood, Angular uses the RxJS library, which introduces observable objects. These allow us to subscribe and listen for values returned over time. The subscribe method can take a simple callback, like an arrow function, or, like we're doing now, an object with the keys next, error, and complete. For us, the most important one is next, because that's where the response from the server is returned. If an error occurs during the HTTP request, it will be passed to the error callback. Let's also add some extra console.log messages as strings to each function, so that as needed, we can easily tell which log is coming from where. Now, if we take a look at app.module.ts, in the declarations array, we'll see that our new component, posts-table, has been added automatically. However, we still need to actually use this component in our app. Otherwise, nothing will show up in the browser or in the console. So let's go to app.component.html and use the selector of our component. Angular component selectors start with the prefix app, so we just need to insert this like that. Now we can switch to the browser and view the app. Just make sure that both the GraphQL server and the front end are running. You can start them using the scripts we defined in the package.json file. As we can see in the browser, we're getting an error. Null injector error. No provider for HTTP client. This happens because we used dependency injection for the HTTP client, but we didn't add the required import in our module. So, let's go back to the code editor and open the app.module.ts file to fix this. Inside the imports array, let's add HTTP client module. It's important to make sure the import is correct, just like you see on the screen. If it's imported incorrectly, the error might still persist. In my code editor, I can see that HTTP client module is strike through and highlighted. That means it's deprecated and may be removed in a future version of Angular. When I hover over it, I see a suggestion recommending an alternative approach using provide HTTP client. I'm not going to switch to that now because HTTP client module is still the standard way in older versions of that framework. It's possible that starting from Angular version 20, the new approach will become the default. Now, if your app is already running in the terminal, you might want to restart it, just in case the changes weren't picked up properly. Sometimes when there's an error in the console, the dev server started with npm run start may not handle it well, and restarting the terminal helps. As we can see in the app now, we're getting a console log output with the string next, along with the response object we received from the backend. Keep in mind that with GraphQL, the actual response data is always nested inside a data key, so it's something to watch out for when handling results. Also, we can see that all posts were returned, so everything is working correctly. In the post table.component.ts file, Let's go back to the query variable at the top of the file and try to intentionally break the query. For example, I'll remove the name of the query and then check in the browser to see what happens. As we can see, the console.log with the string next is still triggered, and not the one from the error block. This time, the server did return a response, but it included a detailed error message inside. So, even though the query is broken, the GraphQL server responds with a valid HTTP response and explains exactly what the problem is, which is very helpful for debugging. Now, back in the code editor, I'll simply restore the original version of the query. The last thing I want to show you is what happens when we stop our GraphQL server. Up until now, we've been receiving proper HTTP responses with a status code of 200, even when there were issues inside the query itself. Now, after stopping the GraphQL server, we check the browser. And as you can see, an error was thrown. And this time it shows the string ERR, just like we set up in our code. This time, the response status is 0, server unavailable error. So this behaves a bit differently compared to how GraphQL itself reports errors. With GraphQL, even if there was something wrong with the query, the server still returned a valid 200 OK response and included the error inside the body of the response. In this part of the course, we're going to install Apollo Angular, which is one of the most popular GraphQL clients available for Angular. But before we do that, let's answer a common question. Why use Apollo at all? Why not just use HttpClient like we did earlier? Well, technically, yes, you can use Angular's built-in HTTP client to send GraphQL queries. It works, and in fact, we've already done that in this course. But HTTP client is very low level. It just sends an HTTP request and returns the response. You have to manually handle things like caching, managing loading and error states, refetching or updating data, organizing large queries and mutations, typing the responses properly, and writing repetitive post requests for every query. That's where Apollo Angular comes in. Apollo gives us a fully featured GraphQL client with built-in caching, automatic query deduplication, support for fragments, pagination, and reactive updates, a clean service-based API, RxJS integration with observables, excellent TypeScript support. It makes working with GraphQL and Angular much more productive and cleaner, especially as the app grows in complexity. There are other GraphQL clients, like GraphQL-request, but Apollo Angular is specifically built for Angular. It has official support, proper documentation, and follows Angular's best practices. So, for professional Angular apps, especially when working with real GraphQL APIs, Apollo is the go-to solution. As we can see in the documentation for the Apollo Angular library on npmjs.com, in the installation section, we're shown how to install the library. The quickest and easiest way is to simply use the following command: ng add Apollo Angular. You also have the option to install everything manually as listed below, and then create the initial configuration for the Apollo client yourself. But honestly, why do that when we can set it all up with a single command? So, I'm going to copy the ng-add command and switch over to the terminal inside my code editor to run it. In the terminal, I use the command we copied earlier, ng-add Apollo Angular. After a short moment, we get a prompt asking, "Would you like to proceed?" It tells us that the Apollo Angular package will be installed. In my case, it shows version 10.0.3. This version might be different for you, depending on which version of Angular you're using, or simply because a newer version of Apollo Angular was released. I type Y and press Enter to continue. The next prompt asks for the URL of your GraphQL API. Here, I'll paste the same URL we added earlier in our environment.development.ts file. We'll be able to change this later in the Apollo Angular config. Next, we're asked to select the version of the GraphQL library. Important: this is not the GraphQL spec version, it's just the version of the npm package named GraphQL. I'm going to stick with version 16, which is the latest one as of now. In most cases, you can leave it as the latest unless you're connecting to a really old backend that uses an outdated GraphQL spec. So, I simply press enter to continue. After a short wait, everything installs correctly, and we get a confirmation message that all dependencies have been installed. But we also see two warnings or errors in red. Let's take a look. First message mentions a missing dependency, esnext.async_iterable, and suggests adding it to the tsconfig.json. But in our case, this is not necessary, because as we'll see in a moment, our tsconfig.json is already using ECMAScript 2020, and this feature is included by default in newer targets. So we can ignore that one. Second message warning says it couldn't automatically add the setting, allow synthetic default imports. This flag is required by the @apollo/client/core package, so we need to add it manually. I copy the setting, go to the tsconfig.json file, and inside the compiler options block, I add allow synthetic default imports, true. And that's it. Our Apollo setup is almost ready to go. Let's quickly open the graphql.module.ts file. This file was also automatically created when we use the ng-add Apollo Angular command. Inside, we can see a variable called URI, which stores the URL of our GraphQL API. The address here is correct, but earlier in the course, we already saved this value in the environment.ts file. So instead of hard coding it, I'm going to replace it with the API URL variable from our environment configuration. To do that, I'll simply import the environment and change the URI value. That way, the API URL will always be taken from the correct environment file, whether we're in development or building for production. I mentioned that after installing Apollo Angular using the ng-add command, a new file was automatically created for us, and that is graphql.module.ts. This file is responsible for initializing and configuring Apollo in our Angular app. Let's break it down quickly. Inside the file, we have a function called createApollo. We use here HTTP link to create a connection between our front end and the GraphQL server. And we return an Apollo client configuration with a link and a cache. In-memory cache is Apollo's built-in caching mechanism. It stores GraphQL responses in memory, so if you request the same data again, it can return it instantly without making another HTTP request. This improves performance and reduces the number of calls to your backend. Right now, we're using the default setup, but later in the course, we'll take a deeper look at how to customize the cache and normalize data. At the bottom of the file, Apollo is provided to the app through Angular's dependency injection. This registers Apollo so it can be used later throughout the app, just like any other Angular service. Of course, simply adding this to the providers array is not enough. This entire module also needs to be included in the imports array in the app.module.ts file. Also, it's worth mentioning that we don't necessarily have to create a separate GraphQL module.ts file. We could move the entire Apollo setup directly into the providers array of app.module.ts. However, keeping it in a dedicated module makes the code cleaner and more modular. The Apollo Angular configuration could also be placed inside the app.config.ts file, which is where the main application level configuration is usually defined. The Apollo service from the Apollo Angular package is the main tool we'll use to connect our GraphQL queries to Angular. So now, in the posts table.component.ts file, Let's update the constructor and inject the Apollo service as a dependency. This service gives us access to the watch query method, which is the primary way to run queries and stay updated with the data. Watch query allows us to send a GraphQL query to the server and continuously listen for changes if needed. It's especially useful for keeping the UI in sync with your data, since it returns a live observable we can subscribe to. But before we call it, there's one more thing we need to do. We have to wrap our query string inside the GQL function, which is also imported from Apollo Angular. This function parses the query and tells Apollo it's a valid GraphQL document. Without it, Apollo won't recognize the query properly. So, now that we've injected the Apollo service, wrapped our query using GQL, and stored it in our query variable, we can finally call this.apollo.watchQuery, passing here as an argument object with property query. The watchQuery method returns a query ref object, and from that object, we can access an observable called value changes. We can subscribe to value changes just like we did earlier with HttpClient. The object we receive from this observable contains loading, a boolean that tells us if the query is still running, error, any errors returned by the server, data, the actual response from the backend. Apollo automatically manages the loading and error state for us, so we can easily show loading spinners or display an error message in the UI if needed. Once the query completes successfully, the response will be attached to the data property. Let's also add some custom strings inside console.log so we can easily tell in the console which message is coming from which part of the code. This is super helpful for debugging, especially when we're dealing with multiple data sources or service calls. Also, since we're now switching to Apollo instead of using HttpClient, the best thing to do at this point is to comment out or remove the subscription to the getPosts method that we wrote earlier. We're no longer using HttpClient here. Our data will now come through the Apollo service using watchQuery. I've now started both our application and the GraphQL server. As you can see in the browser console, all three console.log statements have appeared. Under the label D, we log the object containing our fetched posts. When we expand this object, we can see that it includes a property called allPosts, which holds an array of 4 posts, just like we expected. Next, we have a console.log labeled E, which shows the error value. In this case, it printed a undefined, which is exactly what we want, because the server didn't return an error, so there was nothing to display here. Finally, under L, we logged the loading property. This tells us whether the data is still being fetched. We can see that it logged false, meaning the loading process has already completed. In the upcoming videos, we'll start using these values, data, error, and loading, to build a fully functional UI and display real content in the app. In this video, we're going to add a ready-made table component from the PrimeNG library. On the primeng.org website, under the /table section, you'll find a note at the top that says you need to import table module in order for the data table to work. If you scroll down a bit, you'll see a code snippet showing a basic table example. That's more than enough for us to start with. We'll add pagination later on, but for now, let's copy this basic example and switch to the code editor. In the code editor, we go to the app.module.ts file and add the proper import, table module, inside the imports array. If you're using standalone components, you'll need to import table module directly in the component file instead. Now, let's go to the posts table component.html file. I'll remove all the content and paste in the snippet we copied from the PrimeNG docs. We'll make a few adjustments. First, change the value property in the p table tag to posts, since we'll soon create a property with that name in our component class. Next, we'll modify the column headers and also remove the 4th column called quantity, which we don't need. we'll rename the remaining columns to match the fields we're working with: ID, title, and views. In the table body, we do the same. Update the template to show ID, title, and views. We use these exact names because our GraphQL server, based on the mock data from db.js, returns objects with these precise field names. If the names don't match, the table will be empty. We'll also rename the letProduct variable to letPost to make it more descriptive. Although technically the name could stay the same and still work, it's just better for readability. Now, let's move to the component class. At the top, we'll create a new property called posts and define its type. For now, we'll write it in a simple way, like this. This tells TypeScript that posts is an array of objects, where each object has an ID, a string, a title, also a string, and views, a number. The ID type is a special scalar type in GraphQL. It's meant to represent unique identifiers, and it's treated as a string internally, but semantically, it means this value uniquely identifies an object. This matches exactly what we've typed in TypeScript. We expect every post to have an ID. Now, just below inside our subscription, we need to assign the value returned from the server to our posts property. We'll do that using the spread operator to create a new array. The response from a GraphQL query is always wrapped inside a data object. Inside that, we have our all posts array, so we access it using data.data.allPosts. We also add the optional chaining operator ? In case the data is undefined. This helps prevent errors in case the server returns a failed response. For example, if the query fails, data might be missing, and trying to access all posts would throw an error. The ? safely stops execution if the value doesn't exist. As we can see in the browser, the table is now displaying correctly, and we can see all 4 posts that we defined earlier in the db.js file. I'm also going to open the developer tools with the F12 shortcut, and here we can confirm that our console.log messages are also showing up properly. In this video, we're going to handle the loading state while fetching posts from our backend. To do that, we'll use the progress spinner component from the PrimeNG library. On the PrimeNG documentation, under the page for progress spinner, you'll find a note at the top that says we need to import progress spinner module in order to use the component. Just below that, we also have a code snippet with a basic pprogress spinner example. We'll copy that and head over to the code editor. First, in the app.module.ts file, we go to the imports array and add progress spinner module. Then, we open the posts table component.html file. Here, we paste the spinner element we copied earlier. We also add a structural directive, ngIf equals loading. This means the spinner will only show when the loading value is true. Next, we go to the ptable element and also add an ngIf directive. This time, ngIf equals posts. This ensures the table is only shown after we fetch the posts from the backend. Now we move to the component class. At the top, we create a new property. Loading equals true. We start with true because by default, the component begins in a loading state. Then, inside our subscription, where we handle the GraphQL response, we simply assign this.loading equals data.loading. Apollo tracks this state for us and automatically returns false once the data has been successfully fetched. We actually need to make one more small adjustment to our HTML template. The condition ngIf equals posts is not entirely correct because posts is an array. And in JavaScript, simply checking if an array exists doesn't tell us if it contains any data. What we really want is to display the table only if the array contains at least one item. So instead, we'll update the directive like this: ngIf equals posts.length greater than 0. This checks whether the array is not empty, and only then renders the table. Now let's check how this works in the actual application. At first glance, it might be hard to notice whether the loading screen, spinner, is even showing, because everything loads almost instantly on a fast connection. To simulate a slower network, we can open the Developer Tools, go to the Network tab, and set a throttling option for this view. Let's set it to 3G, which will give us more time to observe the loading phase. Once that's done, refresh the page and wait for it to load. As we can see, after waiting some time, the spinner appears, indicating that data is being fetched from the backend. Then, once the data is loaded, the spinner disappears, and the table with all posts is displayed correctly. So now we've successfully added visual feedback to show users that something is loading in the background, which improves the user experience significantly. By default, when you use apollo.watchQuery, the loading property in the response is set to false, even during the very first execution of the query. This means that, by default, you have to manually set the loading property to true in your component. Otherwise, the loading screen or spinner won't appear at all when the query starts. And in some cases, you might prefer that loading is set to true once the actual request begins, instead of presetting it manually. To change this behavior, Apollo provides a special configuration option called Use Initial Loading. There are two ways to enable this setting. You can pass Use Initial Loading true directly as part of the config object inside watchQuery every time you call it. Or you can enable it globally when providing Apollo in your app's configuration. Let's go with the second option and update it in our GraphQL module. Now let's open the graphql.module.ts file and update the provide Apollo function like this. This tells Apollo to always set loading equals true by default for the initial response. Now, every time you subscribe to value changes, your component will immediately enter the loading state because subscription will return loading property set to true, and the UI will properly show your spinner or loader without delay. This behavior might actually become the default in the future, as mentioned by the Apollo Angular team in their official documentation. So it's a good idea to start using Use Initial Loading now. It makes loading behavior more predictable and improves the user experience. Now let's switch over to the posts-table component class and continue working from there. Now, in the component class, we need to change the default value of the loading property to false, since we've enabled the Use Initial Loading option in our Apollo configuration. This means Apollo will now automatically set loading equals true during the initial query execution, so we no longer have to do it manually. Next, let's go back to the subscription on the value changes property. Inside there, let's add another console log. This time, we'll log the full data object that we're receiving from the observable. This will help us inspect the structure and see exactly what's coming back from Apollo. Now, let's switch to the browser and test the app to see how the data looks in the console. This time in the application, we can see the first console.log output showing the entire data object. Here, we notice something important. There is no data property containing our posts just yet. Instead, we see a property called partial, which is set to true. This means that the query is still in progress and hasn't finished loading all the data. Additionally, the loading property is also set to true, confirming that the request is still ongoing. However, even with loading equals true, we don't actually see the spinner on screen. Why is that? It's because at this stage, when loading is true, the data object doesn't contain the actual posts yet. So when we try to assign data.data.allPosts to the posts property, we get a type error because data.data is undefined. Only on the second emission from the value changes stream, when the data is fully available and loading becomes false, the assignment works correctly and the posts display in the table. Now let's switch back to the code editor so we can fix this logic and handle the intermediate loading state more safely. We have a few different ways to handle this situation safely so we don't run into errors when the data isn't fully loaded yet. One simple approach is to use a conditional if statement inside the subscription and check if data.loading is not set to true. This way, we only assign the value to posts after loading is complete, which avoids trying to access undefined data. Another option is to check the partial flag in the Apollo response. The partial property is true while the query is still loading, so this is another safe way to wait until the data is ready. We can also use a more concise solution, the nullish coalescing operator, written as double question mark symbol, and it would be data.data.allPosts and then double question mark, and at the end, empty array. This line means if data.data.allPosts exists and is not null or undefined, use it. Otherwise, use an empty array instead. This approach avoids type errors and ensures we always assign a valid array to this.posts, even if the query hasn't finished loading yet. It's clean, safe, and ideal if you don't need to wait explicitly for loading to finish before assigning the data. Let's also delete the line with console.log of the entire data object. It won't be needed. Now that we're back in the application, we can see that no errors are being thrown in the console, which means everything is working smoothly. And if I quickly refresh the tab a few times, you'll notice that the spinner briefly appears, indicating that content is being loaded from the backend. That means our loading state is working exactly as expected. We're showing feedback to the user while the data is being fetched, and hiding it as soon as the posts are ready. We have two methods to fetch data from server: watch query versus query. So, what's the difference? Watch query is used when you want to keep your UI in sync with Apollo's in-memory cache. It continues to emit updated results whenever that data changes within the client-side cache. For example, if the query is refetched manually. But don't mistake that with real-time updates. If you're looking for real-time data pushed from the server, that's where GraphQL subscriptions come in. Unlike watch query, which reacts to client-side cache changes, subscriptions emit results based on events from the server, but we will talk about that later. Now, I will explain what is query in Apollo Angular. In Apollo Angular, the query method is used when you want to fetch data just once, similar to a basic GET request. It sends the request, gets the response, and that's it. There's no tracking or updates after that. It's perfect for static or one-time reads, where live updates aren't necessary. Now inside the posts table component class, we're going to comment out the use of watch query, and instead, we'll use the query method, which is also available from the Apollo service. Just like with watch query, we pass a configuration object where we specify the query property. This tells Apollo what data we want to fetch. The key difference is that with query, we subscribe directly to the method itself. There is no value changes observable here. Another important difference is that query doesn't support use initial loading. This means that the loading property returned from the query will always be false by default, even during the initial request. So we would need to change the loading property back to true in our component class if we want our spinner to work properly. Inside the subscribe block, we'll assign the response to this.posts, just like we did with watch query, and also use a console.log to log the full returned object. Now let's run the app and take a look in the console to see what this structure looks like. As we can see in the browser, our data table is still displaying correctly, even after switching to the query method. In the console, we also see the response object returned from the backend. Just like I mentioned earlier, the loading property is immediately set to false, and we have direct access to our posts through the data property. Now, if I try refreshing the tab a few times, you'll notice that the loading spinner doesn't appear at all. That's because our current implementation relies on the useInitialLoading true setting, which only works when using watch query. Now, back in our code editor, I'm going to comment out the part where we used the query method, and uncomment the previous implementation where we were using watch query. This will bring back the behavior we had earlier, including proper loading state handling thanks to useInitialLoading. An important thing to understand when using the watch query method is that it does not unsubscribe automatically. That means every time the component is created, for example, when navigating back to a route or reinitializing the component, a new subscription is added, and it continues to listen for data changes. If we don't manually unsubscribe, this can lead to memory leaks because the previous subscriptions are still active in the background. Multiple emissions of the same data, which can cause duplicated requests or UI updates. To avoid this, it's important to unsubscribe when the component is destroyed, typically by saving the subscription in a variable and cleaning it up in the ng-on-destroy lifecycle hook. Now let's take a quick look at what watch query actually returns. As suggested by the editor, it returns an object of type queryRef. In the next lecture, we'll need access to this object. So besides managing the subscription, we're also going to store the result of watch query in a separate class property. At the top of the component class, let's define a new property called postquery. We'll type it as a query ref, and since this is a generic type, we'll use any for now. Next, we'll create a private property to store our subscription. We'll call it sub and type it as subscription. This property will help us unsubscribe manually and avoid memory leaks. Now let's move to the interfaces implemented by our component. We'll add the onDestroy interface. This requires us to add the ng-on-destroy lifecycle hook, which runs once when the component is destroyed, for example, when navigating to another page. Now, let's go to the place where we call watch query. Instead of chaining everything together, we'll store the result in the postquery variable and then subscribe to it separately. So we save watch query in postquery property and then separately save our subscription in sub property. With that in place, we can now safely unsubscribe when the component is destroyed with calling this.sub.unsubscribe. This is important because without unsubscribing, each time the component gets recreated, a new subscription would be added, leading to memory leaks and unwanted behavior. Now we're making sure our app stays clean and efficient. In this video, let's talk about a feature called polling. Polling is a simple way to achieve near real-time synchronization with your backend. Instead of waiting for the user to manually refresh the page or setting up complex real-time subscriptions, polling lets you tell Apollo to automatically rerun a query at regular intervals. Polling is useful when you need frequent data updates, but the backend doesn't support GraphQL subscriptions. You want simpler setup than real-time subscriptions. You're building something like an admin dashboard, chat refresh, or notifications list. Keep in mind that polling means more requests to your server, so it's a balance between performance and real-time behavior. So, for example, you could fetch new posts every 5 seconds, or check for updates in a dashboard every 10 seconds without the user doing anything. To enable polling in Apollo Angular, you just need to add a poll interval property to the config object inside watch query. Let's say we will add 5,000 milliseconds. Apollo will now automatically refetch the data every 5 seconds, and if anything has changed on the server, the new result will be emitted through the value changes observable. It's important to know that if you set poll interval to 0, polling is disabled. In other words, the query will only run once, just like a regular watch query without polling. Let's also clean up our code a bit. We currently have separate console.log statements for data, loading, and error. Instead, let's remove those individual logs and replace them with just one console.log that logs the entire result object returned in the next callback. As we can now see in the application, we have two entries in the console, which is exactly what we'd expect. The first log appears when the data is initially being fetched from the server, and the second one shows the actual response once the data has been successfully loaded. However, even though we've set a polling interval of 5 seconds, we're not seeing any additional console logs after that. Why is that? Well, it's because the data we're requesting from the backend hasn't changed during that time. So Apollo doesn't emit a new result, since it assumes nothing needs to be updated in the UI. To trigger a new response and actually see it in action, we'll need to change the data manually. Let's switch over to the GraphiQL tool. You can access it by visiting the URL of your GraphQL backend and then opening the GraphQL Explorer tab. Here, let's create a new mutation. We'll use the create post mutation to add a new post to our backend. We'll provide a simple title and a number for the views field. It doesn't need to be anything specific, just enough to create a new entry. Once the mutation is filled out, we just click Execute Query. After that, let's switch back to our application to see if new data appears in the console, indicating that polling has successfully detected the change and fetched the updated data from the server. As we can see in our application, a new value was indeed emitted in the console. When we expand the logged object, we can clearly see that there are now 5 posts in total. This confirms that the new post was successfully fetched from the backend through polling. In addition, we can also see the change directly in the table. The new post has been added, and we now have 5 records displayed in the UI. Everything is working exactly as expected, and polling is keeping our data up to date automatically. Just a quick note, I'm currently in the code editor looking at the db.js file, which acts as our mock database when using the JSON-GraphQL-server library. As you can see, we still have only 4 posts listed here. The post we created through the GraphQL mutation was not added to this file. That's because this setup is just a mock, and changes made through the API are not saved permanently. So if we stop and restart the server, the data will reset, and we'll be back to just the original 4 posts. It's something to keep in mind when working with this library. It's great for prototyping and testing, but not meant for persistent storage. Now let's quickly switch back to our component class. Here, I'm going to comment out the pull interval option, since we won't be needing it in the next steps of the course. In addition to setting a static polling interval when calling watch query, Apollo also gives us more dynamic control using 2 helpful methods, start polling and stop polling. These methods are available on the query ref object, which we get back when using watch query. This means that we can decide when polling should start and when it should stop, based on user interactions, app state, or even custom logic in our component. This gives us much more flexibility compared to hard coding the poll interval when initializing the query. To start polling, you call start polling and pass it the interval in milliseconds. This defines how often Apollo should refetch the data. When you no longer need to poll, simply call stop polling. This method doesn't take any arguments. It just stops polling immediately. I will just comment that methods because we won't need that. So far, we've looked at polling, which fetches new data at regular intervals. But sometimes you don't want to constantly hit the server. Instead, you only want to update your data in response to a specific user action. That's where refetching comes in. Refetching allows you to manually rerun a GraphQL query. For example, after the user clicks a refresh button, adds a new post, or makes some other change in the app. It gives you more control than polling and avoids unnecessary network requests. Let's go ahead and implement this. First, in our component class, we'll create a new method called refresh. Inside this method, we'll use the refetch function provided by the query ref object we saved earlier. This will rerun the original query and update our UI with the latest data from the server. Now let's add a button to trigger this. Let's open app.component.html where we have p-button element, copy it, and then remove it from that template. We won't use it there anymore. Next, go to the post-table.component.html file, right below the p-table element. Paste the button we copied earlier. Then we'll add an event binding to respond to click events. On the p-button element, we're going to add an event binding for the onClick event. Now, normally in Angular, we'd use the standard click event for regular HTML button elements. But since we're using PrimeNG's p-button component, the library has replaced the native event with its own custom event, onClick. Now, every time the user clicks the button, the refresh method is called, and our query is refetched from the server. We're now back in the application. When I click the refresh button, you'll notice that no new value is emitted in the console. That's because nothing is changed on the server. So Apollo fetches the same data, and since there's no difference, it doesn't trigger a UI update. Let's change that. We'll switch over to GraphQL, where I already have a prepared mutation to create a new post. I'll click Execute Query to send the mutation and add the new post to the backend. Now, let's go back to the app and click the refresh button again. As we can see, a new entry has appeared in the console, which means our refresh method worked correctly. Looking at the data object, we can now see that there are 5 posts in total, which confirms that the new post was successfully fetched from the server. Currently, all our queries and types like getPost variables are defined directly inside the post-table.component.ts file. A better approach would be to separate these concerns from the logic inside the component class. So, we're going to refactor the current code. Inside the app folder, we'll create a new folder called GraphQL. If we had multiple feature modules in our app, it would be a good idea to split GraphQL operations by module, so that not everything ends up inside one global folder. But since we currently only have a single module, app module, we'll just place the GraphQL folder directly inside the app directory. Inside the GraphQL folder, let's create 2 files, posts.queries.ts, where we'll store all GraphQL queries related to posts, posts.types.ts, where we'll define all types related to post operations. Now let's go back to posts-table.component.ts and copy the 2 queries, getPosts and getPost. Then we open the posts.queries.ts file and paste them there. To make these queries available in other files, like in our component, we need to export them. There are 2 ways to do this. Use the export keyword directly above each variable, like this. Or export everything at the bottom of the file in one statement. Either approach works. Choose whichever style fits your preference or your team's convention. Now let's return to the posts-table.component.ts file and update the imports accordingly so everything still works. Here, I select by cursor the getPosts variable and press Alt plus Enter to get an auto suggestion for importing it from the posts.queries.ts file. I scroll down a bit in the editor and do the same for getPost. Once we've added the correct imports, just like I have here, we can move on to extracting our types into a separate file. I now copy all the types we previously created and remove them from the posts-table.component.ts file. Next, I switch over to posts.types.ts and paste them there. Now, we cannot use the same method of export like we did with our queries. It's because in our tsconfig file, we have isolated modules options set to true. That option is set to true since Angular 18. That improves Angular build time and performance. That's why we will use export keyword with every type separately, with post, getPost, getPost variables, table post, and getPosts. Now we need to make sure everything still works by updating the import statements wherever those types were used. This time, we head over to posts.queries.ts and update the imports for any types used there. Here we need to import 3 types: getPosts, getPost, and getPost variables. Next, we head back to the poststable.component.ts file. We also have a usage of one of these types here. The getPosts type is being used with the generic query ref. Once that's done, we've now successfully cleaned up our types and queries, keeping our component focused solely on logic and presentation, and moving all GraphQL-related definitions to dedicated files. The JSON GraphQL server library allows us to fetch any item from our database by its ID. That's why we need to slightly modify our get_post query. In the query named myQuery, we need to add a required variable named $ID and give it the type ID. In GraphQL, we create variables by adding the dollar symbol at the beginning and then specifying its name. After that, it's enough to pass this variable to the post we're querying by providing an ID argument with the value $ID. The exclamation mark after the ID type means that this field is required. Now we need to go to the getPost method. Inside the object passed to the query method, we can add an additional field called variables. This is where we pass an object with the variables we want to use in our query. In our case, we'll pass the ID. This variable is called ID because it's exactly the same name which we used to name variable in our query and assigned their value of $ID. But we need to get that value from somewhere. That's why we'll add a required argument to the getPost method called ID, and its type will be a string. Next, let's go to the HTML template. Here, we're currently getting an error because nothing is being passed to the getPost method, but we can easily fix that by simply passing post.id as the argument. This way, we can pass multiple variables to our queries. We simply include them as additional fields in the variables object alongside the ID field. In addition to passing the variables object in the query method, we can do the same in watchQuery if needed. So whenever you need to pass variables to your query, there's nothing stopping you from doing that with watchQuery as well. Now, back in our application, let's try fetching the post with ID 3. As we can see in the console, everything was retrieved correctly. Let's try again with ID 4, and after expanding the data object, we can see that all the post details were fetched exactly as expected. When using Apollo with TypeScript, one of the most common things we need to do is add types to the data returned from our GraphQL queries. GraphQL servers already have strong types in the schema, so it makes sense to carry that over into our front-end code. There are tools like GraphQL Code Generator that can automatically generate TypeScript types based on your queries and your backend schema. But in this course, we'll be keeping it simple and writing our types manually, which is great for learning and understanding how types work. Let's create a new type called post, which matches the structure of a full post object returned from our backend. A post contains 4 fields: ID, a string; title, a string; views, a number; comment, a string. This means we're creating a custom type named post. It describes an object that should have specified fields. Now let's create a new type called getPost. This type will represent the structure of the full response returned from the backend when we fetch a single post. It will contain one property, post, which matches the naming used in the backend response. We'll assign this field the type we previously created, post. Notice that the post property starts with a capital letter. That's important because it needs to match exactly what the backend is returning in the data object. Now that we've defined this type, we can use it to type our GQL query result. Since GQL queries in Apollo are based on generic types, we can pass this type as the first argument to the generic. At this point, TypeScript might still show an error. That's because the generic also expects a second type for the variables we're passing into the query. For now, we'll just write unknown as a placeholder. We'll fix this in a moment. Now, let's go to the getPost method where we call the query function. If we remove the any type from the data parameter, TypeScript is now able to fully infer the correct type, which is our custom getPost. This gives us full IntelliSense support in the editor. So when we write data and press the dot, we immediately get suggestions showing us that the object contains other fields like loading, partial, and data, which contains a post property. And inside it, we see all the fields: ID, title, views, and comment. This is the power of combining TypeScript with Apollo Angular. You get real-time feedback and fewer errors, all while writing cleaner, self-documenting code. Now let's return to the place where we previously created our types. This time, we'll add a new type called getPostVariables. It will contain just one field named ID with the type string. Now that we've created this type, we can pass it to the GQL function instead of using unknown. It's very important to type your variables as well, because if we now go back to the getPost method, specifically to the variables property inside the query method, we can see that we have full type checking and auto completion, indicating which fields should be included inside variables. Let's temporarily remove the ID to see the error displayed in the editor. As we can see, a message appears indicating that the property named ID is missing. These kinds of hints are very helpful when working with GraphQL. Let's also create type for our all posts which we fetch to display in table. We will name it TablePost and use their utility type called omit. It is TypeScript feature which allows us to create type based on another type and omit some fields from that type. We will omit here comment field because we do not fetch that. We will also create getPosts type, which will contain all posts field, and type, for it will be our TablePost array. With that types, we can move to our get_posts query and add here getPosts type to a generic. As a second argument, we pass unknown because we don't want to set a type for variables. Next, move to outWatchQuery method, where we fetch all posts. Here, just delete any type from data object. Currently, if we write console.log data.data in our subscribe block, we don't get any type suggestions about what's being returned from the backend. Let's fix that by going a little further up in our code to where we define the posts query property. Right now, it's typed as query_ref with any type. If we try to remove the type completely, TypeScript will give us an error. Generic type query_ref requires between 1 and 2 type arguments. So in order to get accurate IntelliSense and type safety, we need to replace any with our custom getPosts type, the one that describes the response structure from our getPosts query. Here, the first type argument is used for the result data, and that's all we need right now. But if we wanted to, we could also add a second argument. That would define the type of variables passed into the query, just like we did with getPostQuery. Now, if we go back to our console.log data.data, we'll see that TypeScript now knows exactly what's inside that data object. It suggests that we have a property called allPosts, and that it contains the array of post objects returned from the backend. This gives us clear structure, prevents bugs, and makes working with the data much easier. However, we need to keep in mind that we can't leave the console.log as it is. That's because we have the use initial loading option enabled, and on the first emission from the value changes subscription, the data object is not yet available. So, trying to access data.data too early could result in error. For now, since we don't need the log anymore, I'll simply remove the entire console.log statement. This keeps our code cleaner. We're now inside the db.js file, which serves as our mock database. I've made a small update to this file by adding a new key called comment to each post object. In this video, we're going to focus on fetching a single post, which will trigger by clicking a button. The reason I added the new comment field is to simulate a common scenario. In our app, we might be displaying a list of posts with only partial data, like just the ID, title, and views. But sometimes we'll want to fetch full details of a specific post, including the comment field. For example, when a user clicks View Details. You'll also find the updated db.js file available as a downloadable resource below this video. Let's go back to the poststable.component.ts file. First, we'll rename the existing query. Instead of using the generic variable name query, let's rename it to get_posts, using uppercase letters for clarity and consistency. Now, we'll create a new query and name it get_post. This one will also use the GQL function and backticks to define a multi-line GraphQL query. I prepared this query thanks to our backend explorer we used before. For now, we'll hardcode the ID of the post we want to fetch. Let's use ID1. Later on, we'll make this dynamic, but for now it's good enough to test. Next, let's define a new method in the component class called getPost. We'll give it a return type of void. Inside this method, we'll use the Apollo service and call the query method. We could technically use watchQuery here too, but in this case, we just want a one-time fetch. We're not trying to track changes. So we'll pass in a config object with the query set to getPost and subscribe directly to the observable that query returns. For now, we'll just log the full response object to the console. Now, we also need to make a few changes in the HTML template. So let's open the poststable.component.html file. First, let's add a new empty th element in the table header. Next, in the tr section of the table body, we'll add a new column. Inside this td column, we'll insert a PrimeNG P button component with the label details. We'll also bind the onClick event to the getPost method we just created. Now let's switch to the browser and test the result. As we can see in the browser, the Details button now appears in every row of our table. Let's go ahead and click any one of them. In the console, we can see a log with a data object, and inside it, we have a post key. When we expand it, we can confirm that we've successfully fetched the post with ID1, which makes sense since we hard-coded that value in our query. Now the next step is to make the query dynamic, so that we can pass the ID of the post that was clicked and fetch the correct data for that specific item. But we're missing something here. The comment field isn't showing up in the response. That means we need to go back to the code editor and update our GraphQL query to include the comment field. Back in the code editor, in the posts-table.component.ts file, we'll go to the getPost query. Here, we simply add a new line with the field comment. That's all we need. In GraphQL, just adding the field name is enough to include it in the response. Let's talk about GraphQL fragments, a really useful tool that can make your code cleaner, more reusable, and easier to maintain. In GraphQL, we often write queries or mutations that request the same fields over and over again. For example, you might ask for ID, title, and comment in multiple different places across your app. This repetition can become a problem, especially in larger applications. It leads to code duplication, and updating one field means editing many queries. Fragments solve that problem. A fragment in GraphQL is like a reusable piece of a query. It lets you define a set of fields once and then use it anywhere in your queries or mutations. Let's say we're working with a post type and we always fetch the same fields: ID, title, and comment. We can define a fragment like shown in the presentation. Now, instead of repeating those fields, we just use the fragment. Fragments help you stay dry, don't repeat yourself, and make your queries much easier to maintain. Change one fragment, and it's updated everywhere. Now let's create a new file inside the GraphQL folder. We'll name it posts.fragments.ts. Inside this file, we'll define a variable named post_table_fields_fragment when written in all capital letters. We also need to export this variable so we can use it in other files. When creating fragments, we continue to use the GQL function just like we did with regular queries. Here, we'll be writing in GraphQL syntax. We simply write a fragment named post_table_fields. After the on keyword, we need to specify which type we are creating the fragment on. In our case, it will be the post type, because here we provide the type that exists on the backend. I'll show you where it came from in a moment, but now, right below that, in the curly braces, we define the fields we want. In this case, ID, title, and views. Let's now switch over to the URL of our backend. Here, we have a section called Documentation Explorer. This is exactly where we can check which types are declared on the backend and which ones we should use when creating our GraphQL fragments. When I click on Query, under Root Types, we can see all the available fields. We are specifically interested in the post type because that's the type we're creating our fragment for. So that's where the syntax in our code, fragment post table fields on post, comes from. We're telling GraphQL this fragment applies to the post type as defined in the backend schema. In the posts.fragments.ts file, I'm going to update the variable name to remove an accidental S at the end. Just a small correction. After that, I'll copy the full variable name and then switch over to posts.queries.ts. Here we have two separate queries that are both using the fields ID, title, and views. This is a perfect moment to use our fragment in both queries, so that in the future, if we ever need to update the fields, we'll only need to change them in one place, instead of editing every query separately. To include the fragment, we first need to insert the variable inside the GQL string. In JavaScript, when using template literals, backticks, we can inject variables using the $sign and curly braces. So right inside the GQL template, I'll place post-table-fields-fragment. This brings the actual fragment code into our query. I'll do the same for the second query. Now that the fragment is inside our queries, we also need to use it in the GraphQL syntax itself. To do that, we just write the dots and post table fields wherever we want to spread the fragment. That's the name we gave it when we defined it. So I'll add 3 dots, post table fields, in both queries where we want to include those shared fields. In the getPost query, I'll also leave the comment field as it is, since that field is not part of the fragment, and we still want to fetch it separately in this specific query. The next topic we'll cover is how to add headers to a request that we send to the server. This is important because in many real-world applications, the server will require things like authorization before allowing us to fetch or modify data. For example, if you're using JWT tokens for authentication, you'll need to include that token as a header in every request sent to the backend. A very simple way to do this is by using the context property inside the configuration object of the watch query or query method provided by Apollo. You just add a context key, which holds an object. Inside this object, we define a headers property, and here we can either create a new HTTP headers object or simply use plain JavaScript object syntax, curly braces, where the keys represent the header names and the values are the corresponding header values. Let's try it out. We'll add a custom header named auth and give it a value of test, just to simulate what it would look like when passing a real token to the server. Now, let's switch to the browser. In the Developer Tools, under the Network tab, we can find the request sent to the server. We can identify it by looking at the Payload tab. you'll see the GraphQL query that fetches all posts. So we know this is the exact request where we added the auth header. Now let's switch over to the request headers section. Remember, what we send to the server is called the request, and the data we get back is the response. As we can see, in the list of request headers, there's our custom auth header with a value test exactly as we set it. However, the approach we just used, adding headers manually in each watch query or query call, is not ideal. It leads to a lot of duplicated code, especially if we need to include the same header across multiple requests. If we know that we want to send the same header with every request, there's a better solution. Let's switch over to the code editor, and I'll show you how to handle this globally. Inside the graphql.module.ts file, where we have the create Apollo function, we now need to define a new variable that will handle setting custom headers globally. We'll do this by creating a new variable inside the create Apollo function, and we'll name it auth. We assign it the result of calling the setContext function, which will import from @Apollo Client link context. This setContext function takes a callback as an argument, and the callback itself receives two arguments. We can name them operation and context. The callback must return an object with a headers key, and inside that, we define any headers we want to send. In our case, we'll add a header called auth with the value test. Now that we have the auth variable, we need to inject it into the link property of the object returned by create Apollo. To do this, we'll use the Apollo link utility, which we import from @apollo/client/core. Specifically, we'll use the apollolink.from method, which takes an array of links and combines them. Our array will contain two elements: auth, the link that sets our headers, http://link.create, the HTTP link we were already using. You can pass multiple elements into this array if needed. For example, we could create another variable using setContext, let's say count, that adds a count number header, and include it alongside auth in the array like this. This works like a middleware logic or Angular interceptor logic. Let's now switch back to the posts-table.component.ts file. Here, I'm going to remove the use of the context property from the watch query call, because we're already adding the same header globally through the Apollo configuration. There's no need to define it in both places. Now, back in the application, let's try fetching the details of a single post. A new request should appear in the Network tab of the Developer Tools. Let's open that request and go to the Request Headers section. As we can see, the auth header is also present here, which means our global header configuration is working perfectly. Every request sent from Apollo now automatically includes the auth header, just as we intended. In this video, we'll talk about a key setting that becomes important when your app uses cookies for authentication, and that setting is called with credentials. If your app runs in the browser and your backend handles login and session management using cookies, then, by default, those cookies won't be sent with GraphQL requests unless you explicitly allow it. This is where with credentials comes in. With credentials is a setting that tells the browser to include cookies in requests sent to the server. It's especially important when you're working with authentication like login sessions. The server expects a session ID or JWT stored in a cookie. Without with credentials, your app might fail to authenticate or lose the session, even if the user is technically logged in. In Apollo Client, this option is passed to the HTTP client behind the scenes, specifically in the HTTP link that sends your queries. By setting with credentials equals true, you make sure that every request automatically includes any cookies that your server might be expecting. Now, in the object we pass to HTTP link.create, we can simply add the key with credentials and set it to true. If you were working with an authentication system that uses session cookies, this would be essential to ensure that your credentials are properly sent with every request. But if we try to use with credentials true with JSON GraphQL server, we run into a problem, and it's related to something called CORS, cross-origin resource sharing. When with credentials true is enabled, the browser expects the server to be very specific about who is allowed to make requests. But JSON GraphQL server sends a response with this header: access-control-allow-origin with value set as asterisk. That asterisk means allow any origin, a public wildcard. When the browser sees with credentials equals true, it refuses to accept a wildcard asterisk in that header. It wants the server to say exactly which origin is allowed, because sending cookies is considered sensitive. This is a security feature in all modern browsers to prevent your private cookies from being sent to just any website. So if we use with credentials true, the server must respond with specific origin in access control allow origin header. I just deleted with credentials property from http link.create. We are now working inside the GraphiQL tool. In this video, we want to implement a way to fetch the total number of posts stored in our mock database, which is defined in the db.js file. This will be useful later on when we implement server-side pagination, rather than relying on the front end to handle it. The library we're using, JSON GraphQL Server, gives us access to a special field called All Posts Meta. This field contains metadata about all posts in the backend, including the total count of posts. We can also apply filters here, for example, to check how many posts have more than 800 views or match other criteria. But for now, we simply want to fetch the total number of all posts. So we'll just query all posts meta and request the count field. One important thing to remember about GraphQL is that you can combine multiple queries in a single request. So, alongside all posts meta, we can also fetch all posts or any other data we need. And that's exactly what we'll do next in the code editor. Inside the posts-table.component.ts file, I'm going to add a console.log inside the subscription to the query ref returned by watch query. There, I'll log the entire data object so we can see what's being returned from the backend. Next, let's navigate to our getPosts query. To do that quickly, I'll hold down the left control key on the keyboard and then left-click on the getPosts variable name in the code. That will take us directly to where the query is defined. Next, inside our query named myQuery, I'll simply add the new field related to underscore all posts meta, just like this. Now let's head back to the application and check the browser console to see what gets logged from the backend. In the console, we can see that two objects were logged, but the one with the partial key isn't important for us right now. The one we're interested in is the object that contains the data key. And as we can see, inside that object, there's now a new key called allPostsMeta, which means our query worked correctly. Inside underscore allPostsMeta, we also have a count property, and that gives us the total number of posts as a number. Now that we've confirmed it's working, let's go back to the code editor. Back in the code editor, we need to slightly modify the getPosts type we created earlier. To quickly navigate to it, I'll once again hold down the left control key and left-click on getPosts. Inside that file, just above the getPosts type, I'll create a new type called PostsMeta, and here I'll define a property called count with the type number. This allows us to go back to the getPosts type and add a new property named allPostsMeta with the type PostsMeta. Now, let's switch back to the posts-table-component.ts file. At the top of the class, I'll define a new property named PostsTotalCount set its type to number, and give it an initial value of 0. Next, we scroll down to the subscription block where we previously added a console.log. I'll remove that log now and instead write this.poststotalCount equals data.data.allpostsmeta.count. Thanks to the properly defined types, we now get full autocomplete and type suggestions, making it clear exactly what fields are available and helping prevent mistakes. Of course, at this point, we'll start seeing errors, because the data object isn't immediately available when the request is first made. We can easily handle this by using a simple if condition. All we need to do is check if the data key exists in the object we receive from the backend. If it does, then we safely access allPostsMeta.count. This check is enough to protect us from errors and ensure the app runs smoothly even while data is still loading. Now we're going to add server-side pagination to our application. To start, we first need to update the GraphQL query that fetches all posts. We'll define two new variables at the top of the query, just like we did earlier with the $ID variable in the getPost query. Let's call them $perpage and $page. Both will be of type int, but without the exclamation mark, so they're optional variables. Next, we'll pass these variables as arguments to the allPosts field. The arguments will have the same names, perpage and page, but this time without the $signs. And why those names specifically? Because JSON-GraphQL server supports pagination by allowing you to pass page and per page arguments to limit how much data gets returned from the backend. You can easily experiment with this in the GraphiQL. Of course, this behavior depends on how the server is implemented. Some servers might use a different approach. For example, instead of page, they might use an offset argument, where you specify how many rows to skip before fetching data. But in our case, we'll go with page and per page, which is fully supported by JSON GraphQL server. Now that we've updated our query to support pagination, let's switch over to the posttable.component.html file. Here, we're working with the ptable element. The great thing is that the PrimeNG table component does most of the heavy lifting for pagination. We just need to provide the right values using property binding on the ptable element. First, we'll enable pagination by setting the paginator property to true. Then, we'll set rows per page options and pass in an array of numbers, 2, 5, 10. This property defines the available page size options. In other words, how many rows the user can choose to display per page. We still need to add property binding for the rows attribute. This property controls how many rows should be displayed per page. Since our first option in rows per page options is 2, let's bind rows equals 2 to match that as the default. This will ensure the table shows 2 rows per page initially. For now, let's leave the rest as it is, and check how this behaves in the application. As we can see in the browser, the table is currently displaying 2 records per page. We can, of course, change this to show 5 or 10 records using the dropdown. And if we switch it back to 2, we now have the option to navigate to the second page to view the remaining posts. But here's an important note. Right now, this pagination is handled entirely on the front end. What that means is, we're still fetching all posts from the backend in one big request, and then the ptable component just splits them up into pages on the client side. This is fine for small data sets, but when you're dealing with hundreds of thousands of records, loading them all at once can overload the front end, cause performance issues, or even crash the app. That's why we need to change this setup so that pagination is handled on the server side, which is much more efficient and scalable, especially for large datasets. To properly implement server-side pagination, we need to tell the ptable component how many total records exist in the dataset. In a previous lesson, we created a property called posts total records. So now we can use property binding on the total records input and set it to post total records. Next, we also need to enable lazy loading. We do that by setting the lazy property to true using property binding. This tells the component that we'll be loading data on demand, fetching new records from the backend only when necessary, for example, when changing pages. Finally, we need to set up event binding for the onLazyLoad event. This event is fired every time the table needs to load new data, such as when a user changes the page or page size. We'll bind it to a method named loadPosts and pass in the $event object as an argument. $event represents the event object emitted by the component. In this case, it contains all the details about the table's current state, like the page number, number of rows, sort order, filters, etc. In PrimeNG, this event has the type TableLazyLoadEvent, so we'll use that type in our method's signature to get full IntelliSense support. Before we implement that method, let's quickly switch to the db.js file. As you can see, I've added a few more entries to better demonstrate how pagination works. This updated version of the file will be available for download in the course resources. Now let's go back to post-table.component.ts. Here, we'll define our loadPosts method and make sure it accepts a parameter of type TableLazyLoadEvent. We'll call the parameter simply event. Inside the loadPosts method, we'll start by defining two new variables based on the event object. Page equals event.first/event.rows. And size equals event.rows. Event.first tells us the index of the first record to display. Event.rows is the number of rows per page. So by dividing first by rows, we calculate the current page number. For example, if first is 4 and rows is 2, that means we're on page 2 because numerating of pages starts from index 0 in JSON GraphQL server. We store those values in variables called page and size, and we'll use them in our GraphQL query to fetch the correct slice of data. Now let's reuse the logic we already had in ng-on-init, specifically the part where we call watchQuery and subscribe to value changes. We'll copy that code into the loadPosts method. However, since we now need to pass dynamic variables, we also have to include a variables field in the configuration object we pass to watchQuery, just like we did earlier when fetching a single post using an ID. But here's something important to notice. Right now, we're not getting autocomplete or type hints for those variables. That's because in our postsqueries.ts file, we only passed the getPosts type to the GQL function, but we didn't specify the type for variables. So let's fix that. We will create a new type called getPostsVariables. This type will include two properties, per page a number, page a number. With that done, go back to posts-queries.ts and replace the generic unknown type in the second argument of GQL with our new type getPostsVariables. Now we'll have type-safe autocomplete when passing variables into our GraphQL query. Now let's switch back to the posts-table.component.ts file. Inside the variables property we're passing to watchQuery, we'll set per page to the variable size, page to the variable page. We're now seeing an error in our code, and that's because the types aren't aligned correctly with the changes we've made. Specifically, our posts query property needs to know not only the type of the data returned, but also the type of the variables we're passing to the query. So let's fix that. Go to the posts query property declaration in your component and update its type to include both getPosts and getPostsVariables. As we can see in the application, our table is no longer visible at all. That means something's not quite right in the code, and we'll need to make one small fix to get everything working again. Let's jump back into the editor and see what needs to be corrected. In the posts-table.component.html file, we're using the ngIf directive on the ptable element. At the same time, we've enabled lazy loading and bound the loadPosts method to the onLazyLoad event. Since the table is not rendered until there's at least one post because of the ngIf, the loadPosts method never gets triggered, which means the table never even tries to load the data. As a result, we end up with nothing displayed in the app. To fix this, we simply need to remove the ngIf from the table element. As we can see in the application, the table is now displaying correctly. Let's try navigating through the pages 2, 3, and 4. In Developer Tools, exactly a Network tab, we can notice that a new request is made every time we change the page. However, if we go back to page 1 or 2, no new requests are made. The data appears instantly. That's because Apollo Angular is caching the responses under the hood. So, once the data for a particular page has been fetched, it's stored in memory, and Apollo doesn't need to ask the server again. We'll talk more about Apollo's caching behavior later, but before that, we need to refine our pagination logic, because there's actually a better and cleaner way to implement it. Currently, every time we change the page in the table or adjust the number of rows, we're creating a new query ref using the watchQuery method, and then subscribing to its value changes property again. On top of that, all the data fetched is being cached by Apollo Angular and is never released. This isn't the most efficient solution, especially as your app grows and handles more data. So now we'll take a more optimized approach to pagination. The good news is, we don't need to change much to do it. Let's start by moving the logic for creating the query ref and subscribing to value changes back into the ngOnInit lifecycle hook. In ngOnInit, we don't have access to the size and page variables, but we can hardcode their default values for now. Per page will be 2, page will be 0. These are the values we're using by default in the table. Remember that we set rows equals 2 on the ptable component. So now we're creating the query ref and setting up the subscription only once at the start of the component's lifecycle. And that's the ideal behavior. Since we're already listening to value changes, there's no need to recreate the query every time. Next, inside the loadPosts method, we'll make use of our existing posts query property, which holds the query ref object. This time, instead of calling watchQuery again, we'll simply use the fetchMore method. With fetchMore, we can pass an object containing new variables. In this case, the updated per page and page values. So we will set per page as size and page as page. By default, fetchMore will use the same query we originally passed to watchQuery, but it also gives you the option to override that using a query property. In our case, we don't need to override the query. We're just requesting a new slice of the same data, so the default behavior works perfectly. Let's check how it works in our application. Now, if we start clicking through different pages in the table, we can see that new requests are being sent to the backend, which means the pagination logic is working. That's great. However, there's one big problem. Our UI isn't updating at all when we switch pages. Why is that happening? Well, it's due to how Apollo Angular handles caching under the hood. When we call fetchMore, Apollo uses a built-in strategy. It merges the new data from the server with the existing data in the cache. After the merge, it re-renders the UI with the updated results. But here's the catch. In order for that merge to work properly, Apollo needs some guidance on how to handle merging for specific queries or data types. And that's exactly what type policies are for. A type policy is a configuration option that tells Apollo how to identify, merge, and normalize data for a specific type or query in the cache. When we're using Fetch More with pagination, we usually need to define a predefined or custom merge function, in our case for the all posts field. So Apollo knows how to update the UI with new data, instead of just ignoring it. We'll define this policy in the configuration object we pass to in-memory cache, which is part of our createApollo function in the graphql.module.ts file. With the right type policy in place, Apollo will know how to properly handle pagination and trigger a UI update every time Fetch More is called. That's why we need to use the type policies property in the configuration object we pass to in-memory cache. This property lets us define custom behavior for how Apollo manages the cache for specific types and fields. In our case, we're dealing with a query, so inside type policies, we define a key called query. Then, within that, we define a fields object, which is where we specify caching rules for individual fields. The field we care about here is all posts. It's exactly the same name which we use in our query getPosts. To handle this properly, we'll assign a built-in Apollo helper function to it, offset limit pagination. This function is designed to work with pagination patterns like ours, where you pass variables like page and per page. It tells Apollo how to merge paginated results into the cache correctly, so your UI will update as expected when you use Fetch More. We'll talk more about Apollo's caching system and how it works behind the scenes in the next section of the course. But for now, let's switch back to the application and see how our updated pagination logic works in action. As we can see in the application, each time I change the page, the view updates with a new set of posts, just as expected. That means our pagination is now working perfectly and pulling fresh data from the backend on demand. We are currently in the PrimeNG documentation, specifically in the section for the toast component. We're going to set it up so we can use it later to display error messages in upcoming lessons. To get started, we need to import the toast module, and we'll also use the message service provided by PrimeNG, so we'll need to add that to the providers array. I'll copy the ptoast tag from the documentation and paste it into our HTML later. Let's switch over to the editor. Inside app.module.ts, we'll import toast module and add message service to the providers array, since we'll be using it to show toast notifications. Then, in app.component.html, right at the top of the file, I'll insert the p-toast tag. This is necessary for the toast messages to render properly in the UI. At this point, we could already start using the p-toast component. But before that, let's create a helper service to make things cleaner. In the terminal, I'll run ng generate service core/services/toast. This creates a new service called toast service. Inside that service, I'll inject the message service by writing the following in the constructor. Private message service. Now let's create a method inside the service called showError. This method will take a single parameter named message of type string. Inside the method, we'll call this.messageService.add. We'll pass an object with the following properties. Severity with value set as error. Summary, also value as error. Detail set to message argument, and life set to 2000. This controls how long the toast stays on screen. For us, it will be 2 seconds. Now, let's switch over to the poststable.component.ts file. Inside the constructor, we'll inject our custom toast service. This will let us quickly test if everything is working correctly. Right inside the ngOnIt lifecycle hook, I'll call this.toastService.showError. This will trigger the toast with a sample message saying test. Let's switch over to the application and see if it shows up properly. As we can see in the application, a sample toast message appears when we refresh the page. So we've successfully configured the PrimeNG toast component. Now let's head back to the editor. inside the component class, I'll simply remove the showError call from the ng-on-init so it doesn't interfere with the next lectures of the course. In any application, whether it's a simple to-do list or a large-scale enterprise dashboard, errors are unavoidable. What matters is how we handle them, and more importantly, how we communicate those errors to users. Now, when working with GraphQL, the way errors are structured and reported is slightly different from traditional REST APIs. So let's break that down. When building Angular apps with Apollo and GraphQL, we can face several categories of errors. GraphQL errors. These happen within a GraphQL operation, for example, requesting a field that doesn't exist or violating a validation rule. What's unique here is that GraphQL can still return data and an error at the same time. These aren't full request failures. Server errors. These are more traditional, like when the server crashes, times out, or returns a 500 status. These stop the operation entirely. Apollo client errors. These are internal errors thrown by Apollo itself, such as cache misconfigurations, invalid queries, or improper usage of the client. By default, Apollo is strict about GraphQL errors. If there's a GraphQL error, Apollo treats the entire response as failed. It won't store anything in the cache, and you'll get an Apollo error in your component. But sometimes you might still want the partial data, especially when GraphQL returns valid data along with non-critical errors. To customize this behavior, we use the error policy setting. You can configure this per request or even globally if needed. In our component, posts-table.component.ts. Inside the getPost method, we're going to add a new property to the query configuration called error policy. By default, Apollo Angular uses none as the error policy. So let's explicitly set that for now, even though technically it won't change the behavior yet. This setting tells Apollo to treat any GraphQL error the same way as a network error, meaning no data will be returned, even if the response includes partial data. Now let's test how this works. Navigate to our get_post query and break it on purpose. For example, by adding a non-existent field like test into the query. Once you save that, switch over to the application and let's see what kind of error gets displayed in the browser console. Now, if we click the Details button in the app, we'll notice that an error appears in the console, just like when we run into a network error. This is exactly how Angular behaves when using HttpClient and an error occurs during a REST API call. It throws an error object, and no data is returned. Apollo behaves the same way here, because we're still using the default error policy, none. Now let's switch back to the editor and see how we can handle this type of error and display a proper message to the user. Now let's update the code to handle both success and error cases more clearly. Instead of passing a single callback directly to subscribe, we'll pass an object with two keys, next and error. Under next, we'll place the callback we were already using, but this time, let's update the console.log to display the entire data object. Then, under error, we'll define a new callback function. Inside it, we'll add a console.log displaying string, error, and value, which we get from callback in error property. We'll also show the error to the user using our toast service. vits.toastService.showError with string error occurred, please try again later. This way, users will be informed when something goes wrong, instead of just seeing a blank UI or having to open the dev tools. Now, when we click the Details button in the application, we can see that our toast notification appears. So, the error was handled correctly. In the browser console, we also see our console.log output, but this time, there's no red error stack trace, which means we've successfully caught and handled the error ourselves, instead of letting it bubble up as an unhandled exception. Now, We have posts fetched from the server and displayed in our table. I will turn off the GraphQL server just to show how it will react to a network error. Now, when we click the Details button, after a brief moment, we get our toast notification again, and we also see our console.log output in the console. This means we've successfully handled both GraphQL errors as well as network level errors. Now, before we continue, make sure our GraphQL server is running again, since we turned it off earlier while testing network error. Back in the code editor, let's update the error policy in our getPost method. Change it from none to ignore. This setting tells Apollo to ignore GraphQL errors, but still allow access to any valid data returned in the response. However, it won't report those errors to your UI or save them in the cache. Let's head back to the application and see how this behaves in action. Now when we click the Details button again, we see that a normal response object is logged in the console, just like we'd expect from a successful request. Since we're now using error policy ignore, GraphQL errors are completely ignored. They're not shown in the UI and won't trigger our error callback. We still get a data key in the response, but in this case, it holds undefined. That's because of how JSON GraphQL server behaves when the query fails and there's no partial data to return. If this were a real GraphQL backend that returned partial results, we'd still be able to access and use that data here. Also keep in mind, for network level errors, the behavior is always the same, regardless of what you set as your error policy. Now let's change the error policy to all in the code editor. This is the last possible variant. Let's see how it looks in the browser in the application. Using the all error policy is a great way to inform users about potential issues while still displaying as much valid data as possible from the server. Apollo saves both the data and the errors in the cache, so your UI has access to both and can react accordingly. As we can see now in the console, after clicking Details, the response again includes an object with the data key set to undefined. However, this time there's also an errors key, which is an array containing details about the GraphQL errors returned by the server. This means that if our server were to return partial data along with an error, we could still display the available data to the user and also show a message explaining what went wrong. In the code editor, I'll comment out the use of error policy as well as the entire callback block associated with the error key, because in the next lesson, we'll take a different approach to handling errors. In the graphql.module.ts file, we'll try to handle errors globally. First, at the top of the file, let's create a toast service variable and use the inject function to inject our toast service. This allows us to use dependency injection to access the service outside of a traditional class-based context. Next, we'll create a variable called errorLink and assign it the onError function. This is a special utility provided specifically to handle GraphQL errors globally by adding a new link to the underlying Apollo link chain. The onError function takes a callback as an argument. This callback receives an object with the following properties. Operation: the GraphQL operation that caused the error. Response: the response object from the server. GraphQL errors: an array of errors returned by the GraphQL endpoint. Network error: any error that occurred during the link execution or as part of the network response. We're mainly interested in the GraphQL errors and network error keys. We can use a conditional if statement to check whether any of these errors are present in the current request. For example, we'll write if GraphQL errors, and since it's an array, we can use the JavaScript .map method to iterate over it. Inside the .map callback, we can access the individual error object, which contains a message property. For now, let's just log a message to the console like console.log GraphQL error and pass here property message. For network error, we'll follow a similar approach. we use another if statement, and if the error is present, we log it like this. Console.log network error.message. After making these changes, there's one more thing to do. Since this is another link stored in a variable, we need to add it to the array inside ApolloLink.from. This way, the error link becomes part of the chain of Apollo middleware links and will be executed as part of every request. Let's check in our app how it works. As we can see in the application, when we click on details, our console.log with the message GraphQL error appears in the console. I'd also like to add that each object inside the GraphQL errors array contains an extensions key. In our case, this will be undefined because we're using JSON GraphQL server. However, many GraphQL server implementations make use of the extensions field to pass additional information, such as a custom error code that indicates the type of error. This allows the client to respond accordingly. For example, if the server returns a code indicating that the authentication token has expired, the client could automatically try to resend the request using a refresh token. Or if the code points to invalid input data, we could display a proper error message to the user. For now, instead of iterating through all elements of GraphQL errors, we'll simply access the first item in the array using index 0 and display an error using our toast service. We'll use toastService.showError and pass a message like on the screen. We'll do the same for network error. If a network error occurs, we'll call toastService.showError and pass string network error, please try again later. Now in the application, when I click on details, we can see that our GraphQL error message appears. Additionally, now that I've turned off the GraphQL server, if I click on details again, a network error message appears, which means everything is working correctly. Let's make one final change. In the posts.queries.ts file, we'll remove the extra field we added to the query earlier, which we use for testing error handling. Caching in Apollo Angular is a way to store the results of GraphQL queries in memory. This allows your application to serve data quickly without making unnecessary requests to the server, improving performance and responsiveness. Apollo Angular uses in-memory cache by default. You typically configure it in your app.config.ts or graphql.module.ts file like this. This sets up your application to cache all GraphQL data in memory. We can use some configuration properties with in-memory cache object. Add type name. When true, Apollo adds the 2 underscores type name field to every object. This helps uniquely identify object types and improves cache normalization. Default value is true. We saw type name field before when fetching data from GraphQL server. Result caching. When enabled, Apollo returns the exact same object if the result hasn't changed between queries, helping optimize re-renders in Angular components. By default, it's set to true. Possible types. This is useful when working with interfaces or union types, allowing you to help Apollo interpret the shape of your data. Apollo's in-memory cache uses normalized caching. It stores data like a flat database, where each object is stored by its unique identifier. So if multiple queries return the same object, Apollo will store and reference only one version of it. This avoids duplication and ensures data consistency across your app. You can define how specific types or fields should behave in the cache. For example, how lists are merged, when data is overwritten, etc., like we did in type policies key. The fetch policy option in Apollo defines how your application interacts with the cache and the network when it performs a query. It controls whether Apollo should use cached data, make a network request, or both. Choosing the right policy is key to balancing performance, accuracy, and responsiveness. Cache first is default option. Apollo looks in the cache first. If data is available, it returns it immediately and does not hit the network. If not, It fetches from the network and stores the result in the cache. Cache only. Apollo only checks the cache and never makes a network request. If the data isn't in the cache, the query will fail. Network only. Apollo always makes a network request, ignoring the cache. The result is saved to the cache, but not used immediately. Standby fetch policy behaves similarly to cache first. It checks the cache first before fetching from the network if needed, but with one key difference. The query won't automatically refresh when the cache data it depends on changes. However, you can still trigger updates manually using methods like refetch or update queries. No cache. Apollo always makes a network request, but doesn't store the result in the cache. When working with GraphQL, we usually start by fetching data using queries. But there's also another very important operation: mutations. Mutations in GraphQL are almost identical to queries when it comes to syntax. The only real difference is that we use the keyword mutation instead of query. This small change signals that we intend to modify the dataset behind the GraphQL schema, whether it's creating, updating, or deleting some record. When we use mutations with Apollo Angular, it's really simple. Apollo exposes a mutate method that we can call directly from the Apollo service. It behaves just like queries, meaning it returns an observable, and inside that observable, we get the familiar Apollo query result object. Now, usually, mutations require some arguments, like the data we want to insert or update. That's why, when we call mutate, we also pass an options object with fields like mutation, variables, and possibly more. One important thing to note: you shouldn't manually handle the mutation result in your components if you don't have to. Why? Because Apollo's cache system will automatically update your UI for you, as long as your mutation returns enough information to identify and update the correct records. If you ever need fine control, Apollo allows you to manually tweak things, but in general, relying on ID-based cache updates will save you a lot of effort. Now let's take a look at a real example of how we use a mutation to delete a post. In this case, we use the mutate method from Apollo. We pass a mutation called delete post, which is a GraphQL mutation. We also pass a variables object. Here, we specify which post we want to delete by its ID. Finally, we subscribe to the returned observable to handle the response. In the subscription, if the mutation is successful, the data callback is triggered. If something goes wrong, the error callback is triggered. So, thing to remember is that Apollo Client automatically updates the cache for us if the mutation result includes enough information, such as an ID. So in most cases, we don't need to manually refresh our UI, the cache will handle it. Of course, if needed, Apollo gives us tools to manually control the cache after a mutation, but most of the time, the automatic cache update is enough. When we look at the GraphiQL tool, after creating our delete post mutation, you can see that I explicitly specified which fields I want the server to return. In this case, ID, title, and views. The return data comes inside the delete post key, and it contains exactly the fields we asked for: ID, title, and views. This is very important because we will need these fields later for proper typing in our TypeScript code. Now, one crucial thing to remember: even if we successfully delete a post by using a mutation, the deletion happens only in the memory of our server. Because we're using JSON GraphQL server, a mock server, it doesn't actually update the database file, db.js, that we created. This means if we restart the server, the data will be reloaded from the static db.js file, and the deleted post will appear again. So always keep in mind, this is mock data, great for testing and learning, but not a real persistent database. I will simply copy a mutation query to use it in the code. Now, Inside our posts.queries.ts file, I'm going to create a new constant called delete post. Of course, we will use the GQL function to define our GraphQL operation. Later, we'll also add proper TypeScript types for even better structure and autocompletion. Inside the backticks, I'm pasting the mutation we previously prepared. But there's one important thing we need to fix. Originally, inside the mutation, we hard-coded the ID, setting it to a specific value like 1. Instead of doing that, we should remove this hard-coded value and properly declare a variable for the ID. Also, because deleting a post requires an ID, we'll add an exclamation mark next to the ID type in the mutation. This tells GraphQL that the ID is a required argument, meaning it must be provided. Otherwise, the mutation will fail. Besides that, there's one more improvement we can make here. We already have a fragment called PostTableFields fragment, which includes the fields ID, title, and views. Exactly the same fields that we are requesting to be returned after the delete post mutation. So, just like we did for get_post and get_posts, we can reuse our existing fragment inside this mutation. This way, if we ever need to add or remove fields in the future, we only need to update them once inside the fragment. Now, let's move to the file where we store all our types, posts.types.ts. As we know, after deleting a post, the server responds with a few fields, ID, title, and views. We already have a type that perfectly matches these fields. It's called TablePost. Even though the name might not be perfect for this case, we'll keep it to maintain consistency across the project. Besides that, remember that the server wraps the deleted posts data inside a delete post field. That's why we'll now create a new type called delete post, which will have a delete post property typed as table post. This way, we will have a properly typed response for our delete post mutation. But that's not all. When calling the mutation, we also need to send some variables to the server. In this case, the mutation expects a single variable, the ID of the post. If you look closely, we already have a type called getPostVariables, which has exactly one field, ID. Instead of reusing the same type to keep things clean and separated, you'll simply copy the structure and create a new type named deletePostVariables. Even though the structure is the same, having separate types for fetching and deleting posts improves code clarity. This way, we clearly separate concerns and make our types more intuitive to understand. Now let's go back to the posts.queries.ts file. Here, we'll update our delete post mutation to use the new types we just created, delete post and delete post variables. By doing this, we make sure that our mutation result and variables are properly typed, just like we did earlier for our queries. Once the mutation is properly typed, let's move to the posttable.component.ts file. Here, we'll create a new method called deletePost. Inside this method, we'll use the injected Apollo service and call the mutate method. Just like with query or watch query, mutate accepts a configuration object, but this time, instead of providing the query property, we'll use the mutation property and pass in our delete post mutation. Also, because deleting a post requires an ID, we'll make sure our delete post method accepts an ID argument of type string. Then, we can pass this ID inside the variables key of the mutate method. Since the mutate method returns an observable, we also need to subscribe to it. However, for now, I won't pass any callback function or an object with next or error keys into the subscription. We'll simply subscribe and see how it behaves this way. Now, let's go to the posts-table.component.html file. Here, I'll copy the existing P button inside our last column and paste it right below. I'll change the label from details to delete. Additionally, I'll add a new attribute called severity, which is provided by PrimeNG and controls the styling of the button. We'll set it to danger to give it a red color, which is commonly used for destructive actions like deleting. Also, in the onClick event, instead of calling getPost, we'll call deletePost and pass the corresponding post ID. To improve the UI a little bit, let's add some spacing between the buttons. Let's quickly jump to the styles.scss file, which holds our global CSS styles across all components. Here I'll create a new class called ML3 and set margin left to 3 pixels. Now going back to posts-table.component.html, on the new delete button, I'll add a class equals ml-3 to apply the margin. Let's now go to the application and see how everything looks and behaves. Now we are back in the application. We also have a post with ID equals 1, because earlier I restarted the server and the posts were reloaded again from the db.js file. Let's now click delete on the post with ID equals 1. As we can see, in the network tab, the request appeared and it correctly returned the data of the post we tried to delete. However, our posts table was not updated, meaning Apollo still did not automatically update our UI. Now here's the real question. How was the library supposed to know that we were deleting this record? It received a response with an object that has the same fields and values as the post we were displaying, and a underscore type name set to post. From Apollo's point of view, there was nothing new to update. The values were the same, and no indication was given that this object should be removed. When I will restart our application, we can see that the new fetched data does not contain post with ID 1, so it was deleted successfully. Let's now go back to the code. Now, I'll show you 2 ways to update the UI after running our post-deletion mutation. The first method is using refetch queries inside the object we pass to the mutate method. Here, we provide an array with an object containing a query key, where we specify exactly which query should be refetched. In our case, that would be getPosts. However, there is a small issue. If we leave it like that, the UI would indeed update, but the query would fetch all posts again without considering pagination. To fix this, we would also need to pass a variables key where we include the pagination variables like per-page and page. And yes, we could easily do that. We could use the viewChild decorator to grab the p-table element from the HTML template and read the current page and number of rows to fetch. But instead, we're going to make it even simpler. I'll remove the refetch queries key, and instead, inside the subscribe callback of the mutation, I'll call a method we already have, this.refresh. This method under the hood uses the refetch function, which will update our UI, and the best part is, it automatically reuses the same variables we initially passed when we first fetched the posts. For now, we'll leave it like this and see how it works. I've once again restarted the server to reload all the posts from the db.js file. Now, let's click delete on post with ID equals 1. As we can see, the post was successfully removed from our UI. Of course, under the hood, this triggered a new HTTP request. However, that's completely fine, because every time we change the page or the number of rows displayed, we are already making a new server request anyway, since we are using pagination. When you perform a mutation in Apollo, like deleting a post, sometimes Apollo cannot automatically update your UI, even if the mutation succeeds and returns data. Apollo provides a special option called update, which is a function you can pass into your mutate call. Inside this update function, you are given access to 2 things. Cache. This is Apollo's local cache memory. Data. This is the data returned by your mutation from the server. With the cache, you can read the current data using read query, and then write new data back using write query. Now, in our case, we have a paginated list of posts. That means when we read from the cache, we need to specify the correct page and size. because Apollo stores different results separately depending on the variables used in the query. For example, get posts with variable per page set to 2 will be saved different in cache than get posts with variable per page set to 3. In the component, we are using viewChild to access the PrimeNG ptable component from our template. The viewChild decorator in Angular allows you to grab a reference to a DOM element or a child component inside your template, so you can interact with it directly in your TypeScript code. In this case, we assigned a template variable called poststable to the table in our HTML and captured it using viewChild poststable inside the component class. We typed it as table, and this is just component class from PrimeNG library. This way, we can access properties of the tables such as first, the index of the first row currently vitable, and rows, the number of rows per page. When we execute the update function after a post is deleted, we first read the current list of posts for the current page and size from Apollo's cache. We do this using cache.readQuery brackets, where we specify the same query, getPosts, and the same variables, per page and page, that were used originally to fetch the posts. Once we have the existing list of posts, we create a new array by filtering out the post with the ID that was deleted. This way, the post is effectively removed from the list without touching the server. After that, we write the updated list back into the cache using cache.writeQuery, again providing the same query and variables, but now passing the new list of posts. We also update the metadata that holds the total count of posts by simply decreasing it by 1. This manual cache update ensures that the UI immediately reflects the deletion, without needing to reload data from the server. The PrimeNG table automatically re-renders when the underlying data changes. When we click the delete button on the post with ID equals 1, we can see that the post is successfully removed from the list. However, we notice something strange. The post with ID equals 2 appears twice in the list. In the console, we logged the new posts array, and we can see that it only contains the post with ID equals 2. This behavior happens because when we perform the delete mutation, we only receive back the data of the post that was deleted. We do not get an updated list of posts from the server showing the correct next page of results. Since we manually filtered the deleted post out of the old list without fetching new data, our client-side data became incorrect. In this case, simply removing the post from the local cache is not enough to reflect the true, updated state from the server. As you can see, sometimes you cannot fully rely on cache manipulation alone. In cases like this, where pagination, dynamic lists, or changes in data structure are involved, you do need to make an additional query to the server to refresh the data properly. The good thing is, now we understand how manual cache updates work, and in many simpler cases, such as updating or adding records, Apollo's automatic cache mechanism can handle the updates without needing extra network requests. But for deletions, especially when dealing with paginated data, it's safer to refetch the list after a mutation to ensure that your UI matches the real data on the server. In the code editor, I'm simply going to comment out the entire block related to the manual update of the cache. Instead, I'll uncomment the thisRefresh method that we had previously. This way, after deleting a post, we will just trigger a fresh query to the server and reload the updated list of posts. As for the viewChild decorator that I added earlier to access the table, I'm going to leave it exactly as it is. Inside the GraphQL tool, I've already prepared 2 mutations that we'll be using. These are update post and create post. The update post mutation accepts 4 arguments: ID, title, views, and comment. In response, it returns an object under the update post key, which includes all the fields of a post: ID, title, views, comment. This is important because the returned data will help us update the UI and keep the Apollo cache in sync after a successful update. The create post mutation, on the other hand, expects three arguments: title, views, comment. It does not require an ID because the server will automatically generate the ID for the new post. Now that our GraphQL mutations are properly prepared, let's switch to the code editor and implement everything step by step. Inside the posts.queries.ts file, let's create a new variable called update_post. Here, just like before, we assign it the GQL function, and for now, we use backticks to write the raw GraphQL query. At this point, I will paste the previously prepared mutation into this variable. We'll immediately make some important adjustments. First, we need to remove any default values that were added in the mutation. For example, default title or view values. Also, I'll add an exclamation mark after the ID parameter to indicate that it's required. Other fields like title, views, or comment remain optional, because during an update, we might update just one field or all fields at once. Below that, we create another variable called createPost. Similarly, we use the GQL function and for now paste the same mutation content. Then we update the structure. In updatePost, we only leave the fields related to updating a post. In createPost, we only leave the fields related to creating a new post. In createPost, let's also write exclamation marks on all fields and delete ID property from my mutation. Remember, we must export these variables so we can later import and use them in our component. Additionally, since now we have three different queries mutations, getPost, updatePost, createPost, that all reuse the same fields, like ID, title, and views, plus comment, it would be a good idea to create another fragment, one that includes all fields of a post. Although I'm going to skip this step here to keep things moving, you are absolutely encouraged to create another fragment on your own, one that includes all fields of a post. Now let's move to the file posts.types.ts. Here, we're going to create 4 new types. First, let's define the updatePost type. Inside, we'll have a key called updatePost, and its value will be a type post, because our mutation returns all fields of the post. Next, I'll simply copy this type and rename it to createPost, changing the inner key name as well to match from updatePost to createPost. Now that we have these two types, we also need to create types for the variables that we are sending to our mutations. Let's create a type called updatePostVariables. In this type, we'll include all post fields, but only the ID field will be required. The rest of the fields will be marked as optional by adding a question mark after the field name. This way, we don't have to provide those fields unless we actually want to update them. Only the ID will be strictly required. Finally, let's create another type called createPostVariables. This time, all fields will be required, but we'll only be sending title, views, and comment. We don't send the ID because it will be generated automatically by the server when creating a new post. Now let's return to the posts.queries.ts file. Here, we just need to apply the types that we created a moment ago. Inside the update post, we'll use the updatePost and updatePostVariables types. And for the createPost mutation, we'll use the createPost and createPostVariables types. This way, we've properly prepared both of our mutations for updating and creating posts. In the next lecture, we'll move forward and start working directly on updating posts, and we'll build a simple form for that. For our post form, we'll be interested in 2 PrimeNG components for this part. The first one is pInputNumber. This component acts as an input control that allows users to enter only numeric values. We'll use it to handle the views field when working with our posts. To use this component, we need to import the input number module into our project. The second one is p_input_text. We'll use this one for other fields like the post title and comment. Similarly, to use it, we need to import the input text module. Additionally, for both controls, we'll use the floating label version, meaning the label will float above the input field once the user focuses on it. Specifically, we'll go with the onLabel option shown in the documentation. Inside the app.module.ts file, we need to add the necessary imports. Let's add imports for both input text module and input number module. Now, we can use the terminal to generate a new component. Type the command ng generate component views/post-form. We'll name this component post_form component because it will serve both purposes, creating and editing posts. Inside the class of this component, we'll add a property called post_id. When this post_id is provided, it means we are editing a post. If it's not provided, it means we are creating a new one. Post_id by default will have null value, but it can also be string. Next, let's move to the HTML template of the post_form component. Inside the template, we'll first create a div element. Within that div, we'll add a form element that will represent our form. Inside the form, I'll add another div and paste the code I copied from the PrimeNG documentation. This will be an input field using the p_input_text directive. Below that, I'll add another div, this time containing the p_input number component. Now, let's clean up unnecessary attributes from our input components. For p_input number, we can remove attributes like mode, currency, and locale, as they are not needed in our case. Next, let's update the p_input_text input for the title. Change its ID to title label. Ensure that the corresponding label element has the same value in its for attribute. Also, update the displayed text from onLabel to simply title. For the p_input number used for views, we'll also make similar changes. Update its input ID to views_label. Ensure the label element references the same ID. Change the displayed text to views. Additionally, let's wrap p_input number in its own separate div for better structure. Now, we're still missing an input for the comment field. To fix this, I'll copy the existing div containing the title input and change its ID to comment label. Update the displayed text to comment. Additionally, we don't really need the autocomplete equals auth attribute. We can allow autofill as it might be useful for users. At this point, we're still getting an error related to p_float label. This happens because we haven't imported the necessary module yet. So, let's go back to app.module.ts and add the missing float label module import. After this, the error in our HTML template should disappear. Besides setting up the form itself, we also need to render our new components somewhere in the app. To do this, let's go to app.component.html and simply use the selector of our newly created component, which is app-post-form. After adding it, the form should now appear correctly in the application. Now let's add some styling to make our component look better. First, go to styles.scss. Inside it, we'll define that all input elements and p_input number components should have width set to 100%. This will ensure they always adjust to the width of their parent container. Next, let's create two new utility classes. mt-10 will add a margin top of 10 pixels. mt-20 will add a margin top of 20 pixels. Now, go to posts-table.component.html and copy p_button element so we can reuse it in our form. Head back to post-form.component.html, add the class mt-20 to the main div that wraps the entire form. Then, for each inner div inside the form, where the inputs are, add the class mt-10 to create nice vertical spacing between form controls. Once the layout is prepared, at the bottom of the form, add a new div and paste the previously copied P button inside it. For now, remove the onClick event from the button and set its label to Submit Form. Finally, let's improve the UX by adding a heading. Above the form tag, add an h2 element. Inside the h2, use angular interpolation with a ternary operator. If this .PostID has a value, in our case it's not null, display edit post. Otherwise, display create post. This way, the form will dynamically adjust its title depending on whether we are creating or editing a post. Now let's move to the terminal. Here, we will create a helper service by running the following command: ng generate service core /services/posts. This will generate a posts service for us. Inside the service, let's create a new property called postID$. We assign to it a new instance of behavior subject. Since behavior subject is a generic class, we specify that it can hold either a string or null type, and we set the default value to null. We add a $sign at the end of the property name because that's a common naming convention for observables. And under the hood, a behavior subject is an observable you can subscribe to. We're using behavior subject because we want the ability to emit the ID of a post that we want to update. Now, let's go back to postform.component.ts. Here, we need to inject our posts service by adding it in the constructor using dependency injection. So we add in constructor private post service of type post service. Next, implement the onInit interface and create the ng onInit lifecycle hook. Inside ng onInit, we subscribe to the postID$ observable from the service. Since behavior subject is an observable, we can use the subscribe method and provide a callback function to react to emitted values. Besides behavior subject, there is also subject, both provided by the RxJS library. However, we specifically use behavior subject here because it requires a default value, in our case, null. Subject does not allow an initial value. Its first emission only happens after you manually push a value into it. Thus, behavior subject is perfect when you always want to have a current value available, which fits our use case perfectly. Now let's go to posttable.component.ts. Here, we have the method called getPost. Let's copy the method, but without the subscription part. In real-world Angular applications, when working with HTTP requests to the server, it's a common best practice to separate business logic from the component logic. That's why now we'll move the copied code into our posts.service.ts and paste it exactly as we copied it. Don't forget to add the closing curly brace. Additionally, we need to add the return keyword. This indicates that the method will return the observable created by Apollo's query method. This way, the component can simply subscribe to this observable without worrying about building the request itself. Now, let's go back to poststable.component.ts. In the constructor, let's inject our service, private post service typed as posts service. Now, in the getPost method, instead of using this.apollo.query, we will now use this.postService.getPost and pass the ID as an argument. This way, the business logic is nicely separated into the service, and the component is only responsible for subscribing and reacting to the results. Now let's go to the HTML template. Inside our table, let's copy the existing P button, the one used for details, and paste it below. We'll change the label to Edit. On the new button, let's assign a click event, Edit Post with argument post.id. Now, when I press Alt and Enter on Edit Post, the IDE suggests creating this method inside our component class, and I accept it. Inside Edit Post, we will emit the ID of the post that we want to edit. We do this by accessing this.postService.postID value and calling the next method, where we pass the post ID. Behavior subject provides the next method to manually emit new values to all its subscribers. Now let's see in the application how our form reacts to this. When we click the Edit button in the application, we can see that the heading above the form changes to Edit Post, which means that passing the ID to the form works correctly. Now, inside postform.component.ts, let's add a new property called sub with the type subscription, and assign to it the result returned by the subscription to this.postService.postID$. Since a behavior subject does not automatically complete its subscription, we need to manually upsubscribe when the component is destroyed. We do that by implementing the lifecycle hook ng-on-destroy. And don't forget that we also need to implement the on-destroy interface. Once this is set up, we can move on to creating our form. Since we'll be using reactive forms, we need to import the necessary module. Let's go to app.module.ts, and in the imports array, add the reactive forms module. Now, back in postform.components.ts, we create a new property called postform, and we immediately assign it a new instance of form group. This is how we create a reactive form in Angular. Inside the constructor, we pass an object. It's best if this object has keys that exactly match the fields we want to send to the server. In our case, it will be title, views, and comment. For each of these fields, we create a form control. For now, we'll set the initial value to an empty string, except for views, where we'll set it to null, since this field will hold a number. We import both form group and form control from @angular/forms. If I hover my mouse over the postform property name, I can see a tooltip showing me the current type of this property. This is very useful because we are about to improve our code. We'll move the initialization of the form group to the ng-on-init method instead of directly inside the class property. I'll simply copy the full type that is shown in the tooltip and paste it to explicitly set the type for postform. It's worth mentioning that ideally, this type should be extracted into a separate file as an interface, but for now, we'll stay focused on updating the post first. Additionally, I'll adjust the type of the views field to indicate that it can be either null or number. If there are any type errors later, we'll correct them as needed. We will also remove the direct assignment to the posts form property for now, but I'll keep a copy of it because it will still be useful later. Now, inside ng-on-init, instead of immediately subscribing to the observable, we're going to use the pipe method. The pipe method allows us to react to the data being emitted in a more structured and flexible way. You can think of it similarly to array methods like filter, where you can modify or selectively process data as it flows through. First, we will use the tap operator. Tap doesn't modify the data that passes through the stream, it's mainly used for side effects. In this case, inside the tap callback, we will simply assign the emitted post ID to our this.postID property. It's the same post ID we previously handled inside the subscribe callback. Additionally, inside the tap, we'll add a conditional check. We will write if using the double exclamation marks to explicitly convert the value to a boolean and negate it. This way, if post ID is nullish, null or undefined, the condition will recognize it. Then it'll assign a new form group instance to this.postsForm to reset or create the form. After tap, we'll chain the filter operator. Unlike tap, filter does affect the data stream. It decides whether the data continues downstream or gets blocked. In the filter, we'll pass the post ID again and only allow non-null values through. If post ID is null, the observable chain will stop there and not proceed to the next steps. Next, we use the switch map operator. This operator is extremely useful because it allows us to switch from the original observable to a new observable. Inside the switch map, we get the valid post ID and call this.postService.getPost, returning the observable from that service call. We also need to remember that the post ID we are working with has the type null or string. However, thanks to the filter operator that we added earlier, we have already made sure that the stream won't continue unless post ID is a valid, non-null value. Now, when we finally subscribe, we're no longer receiving just the post ID. We're receiving the full post data from the server. Inside the subscription callback, we can reassign a new form group to this.postForm, but this time we fill it with real data. We assign postData.title to the title field, postData.views to the views field, and postData.comment to the comment field. All the operators we used, tap, filter, and switchmap, come directly from the RxJS library, which is heavily used in Angular applications. These operators allow us to efficiently manage and transform streams of data coming from observables. It's important to understand that using operators like switchmap is much more effective than manually nesting subscriptions inside other subscriptions, which can quickly become messy and hard to maintain. By setting up the flow this way, we're keeping the code clean, readable, and fully reactive. And we make sure that the form is correctly populated only when a valid post is selected. We are still getting a TypeScript error related to the type we assigned to posts form. The issue happens because when we defined the form control, we allowed its value to be either a number or null. However, right now, TypeScript expects the control to have a strict type of null only. It doesn't realize that it could also be number. To fix this properly, we should explicitly define the generic type for the form control as number or null. By doing this, we clearly tell TypeScript that the control can safely hold either a number or null, and the error should go away. In addition to that, we will create a small helper getter called controls. This will simply return this.postForm.controls. Adding this helper getter will make it much easier for us to work with form controls in our HTML template, because instead of writing postForm.controls multiple times, we can just call controls. It's a small but very helpful improvement, especially when templates start to get larger and more complex. Now, inside the HTML template, in the form tag, let's add a property binding for the form group directive. We bind it to our posts form instance from the component class. Next, we need to bind the individual form controls to their corresponding input fields. For the title input, we add a property binding to form control. Make sure not to confuse it with form control name, which is something different. Here, we bind it directly to controls.title. After that, we can copy the same binding setup for the other fields, views and comment. Just update the bindings so that for the views input, you use controls.views, and for the comment input, you use controls.comment. Now, let's move to the P button. Here, we will add an onClick event binding and assign it to a method called onSubmit, which won't take any parameters. Then, I use the shortcut Alt-Enter to quickly generate this onSubmit method in the component class. Now, we need to make one small correction. In the if conditional statement where we check for post ID, I need to remove one exclamation mark. This way, we properly check whether post ID actually has a value. In the filter operator, however, everything stays the same as it was. No changes needed there. Now, let's move on to the post service. Here, we will create a new method called updatePost. It will accept the following arguments: ID of type string, title of type string, views of type number, and comment of type string. Inside this method, we simply return the result of calling this Apollo mutate, because we are performing a mutation. In the object we pass to mutate, we first provide the mutation key, and we import and assign the update_post query variable that we already have prepared. Next, we need to specify the variables key, where we pass all the arguments, that is, ID, title, views, and comment. The mutate method returns an observable, so now we can go back to our postForm component.ts file and use it there. Inside the onSubmit method, let's first create a conditional statement. We will check if this .postID, meaning we only want to run this piece of code if a post ID exists. In other words, if we are editing an existing post rather than creating a new one. Above this block, let's perform destructuring. We will create 3 new variables: title, views, and comment. These values will come directly from the form by calling this.postsForm.getRawValue. This method allows us to easily extract all the current values entered into the form fields. Now that we have these variables ready, we can call this.postService.updatePost. We pass in the following arguments in order: this.postID, title, views, and comment. Since the updatePost method returns an observable, we need to subscribe to it. However, we are not really interested in the result object here. We simply want the update operation to happen in the background. Apollo Client should automatically handle updating the cache data and refreshing the UI after a successful mutation, thanks to its built-in cache management. Finally, make sure to add a return statement inside this block. This will stop the execution of the method after updating a post, because a bit later the same onSubmit method will also handle creating a new post. Adding return ensures we cleanly separate these two actions. Now let's test how everything works inside the application. First, click the Edit button on the record with ID 1. You'll see that all the existing data for this post is automatically filled inside the form fields. Now, let's make some changes. Update the title field to test. Change the views field to 10. And set the comment field to test. After making these changes, click the Submit button. As you can see, the data inside the table updates immediately. This means that Apollo Client successfully handled the UI update for us, exactly as expected. Let's take it one step further. Click the Details button next to this post. When we expand the data object in the console, we can clearly see that the comment field also reflects the new value we entered. This confirms that we correctly handled the data update process, both in the cache and visually in the UI. In the posts.service.ts file, let's create a new method called createPost. I'll start by copying the existing updatePost method, since they are going to be very similar. Now we change the method name from updatePost to createPost. Next, we remove the required ID variable, since we don't need it when creating a new post. We also remove the part where we were passing ID to the variable's object. And finally, we replace the update_post mutation with the create_post mutation. With that, we have fully prepared our mutation for creating new posts. Now let's switch to postform.component.ts. Right below the if block that checks if we are editing a post, we'll call this.postService.createPost. We pass the arguments just like above, so I'll copy the part where we pass title, views, and comment from the update and paste it into the create call. Of course, we also need to subscribe to the result here as well. In the previous lecture, we finished building our form, and now the basic functionality should work. However, let's add a cancel edit feature to make the user experience better. Let's create a new method called clearEdit. It doesn't take any arguments. Inside, we'll call this.postService.postID$next and pass null, meaning we no longer want to edit any post. Now, let's open postform.component.html. Here, I'll copy the existing P button used for submitting the form. In the Submit button, let's add the ML-3 class to create a little space between the buttons. In the New button, we're adding for canceling edits. We'll change the label to Cancel Edit. For the onClick event, we'll assign our clearEdit method. Also, using the severity directive, we'll set it to secondary to give the button a different, less prominent style compared to the submit button. Additionally, let's add a structural directive ngIf to the cancel edit button. We'll bind it to post ID, which means that the button will only be visible when a post ID exists. In other words, only when we are editing a post. If no post is selected for editing, when post ID is null, the cancel button simply won't appear. Now, in the application, let's click the edit button on the post with ID 1. As we can see, the cancel edit button appears. Let's click it, because now we want to add a new post instead. I'll also set the table to display a maximum of 10 records. Now let's add a new post. I'll set the title to test, the views to 11, and the comment to test. I click Submit Form, and as you can see, nothing happens immediately. If I refresh the page and again set the table to show a maximum of 10 rows, we can now see the new post displayed. This confirms that the post was indeed saved to the backend. However, our table uses server-side pagination. We request a specific page and a number of rows from the backend. Because of this, Apollo doesn't automatically update the cache with the newly created post, and it doesn't appear immediately in the table. Let's now find a better solution to fix this problem. As we remember from earlier lectures about deleting a post, we had two options inside a mutation to update the cache data. The first was using the refetch queries key, where we specified which queries should be refetched from the server. The second method was using the update function, where we had access to the Apollo cache and could manually update the data stored there. However, the second solution doesn't fit our case very well, because we don't want to manually update the cache for a table that is fetching data using server-side pagination. Manually updating the cache could easily lead to inconsistencies, and it would be difficult to keep everything in sync. That's why we'll try the refetch queries approach. Here we pass an array of objects. In our case, we'll provide one object with the query key set to our getPosts query, and the variables key where we'll pass two arguments, per page set to 2, page set to 0. At this moment, I'm setting these default values manually. It's not a perfect solution, because ideally, we should get the actual current pagination settings directly from the table, to know which page and how many rows per page the user currently has set. But just to demonstrate how refetching works, I'll leave it like this for now. Keep in mind though, if the user's on a different page or has selected a different number of rows to display than 2, then the results might not behave exactly as expected. In our application, let's add a new post again. Setting, title to test, views to 11, and comment to test. As you can see, after adding the post, the total number of available rows in the table updated automatically. When we switch to the last page, we can now see our newly created post displayed in the table. When we perform a mutation using apollo.mutate, the result object also includes a loading property. By default, loading is always set to false. The result is only emitted once, together with the full server response, coming from the Apollo link execution chain. However, if you want more control and better UX, Apollo allows you to enable a special flag called Use Mutation Loading. When you set Use Mutation Loading to true, the mutation result will first emit with loading true, and later emit a second time once the final result arrives, this time with loading false. This is very similar to the behavior of use initial loading that we discussed earlier when working with queries. One important note, use mutation loading is disabled by default to avoid any breaking changes. It might become enabled by default in a future major version of Apollo Angular. In GraphQL, we typically use queries to fetch data and mutations to change data. But there's a third operation that's especially powerful when we need real-time updates. It's called a subscription. A GraphQL subscription allows the server to push data to the client whenever a particular event happens. Instead of returning a response once, like a query, a subscription keeps a connection open and sends updates as needed. Subscriptions can be used for a chat application, where new messages should appear instantly, or notification system, where updates are pushed automatically. It's tempting to use subscriptions everywhere, but they're not always necessary. Often, polling or manual refetching is enough. Use subscriptions when the initial data is large, but only small updates happen frequently. You want low latency, real-time updates. You're tracking specific events like new comment created or status changed. For proper subscription setup, we need to define a separate transport using GraphQL WS library, then combine it with existing HTTP transport for queries and mutations. This part often involves using split to send subscription operations over WebSocket and everything else over HTTP. To use subscriptions with Apollo Angular, we need a WebSocket connection instead of standard HTTP. That's why we will install GraphQL WS library. This library enables the WebSocket protocol that Apollo can use for subscriptions. Apollo Angular gives us two methods for subscribing. Subscribe directly listens to a subscription and can update multiple parts of your app. Subscribe to more listens to updates for a specific query, often used in pagination or infinite scroll. To work with subscriptions, we can't use the JSON GraphQL server library because by default it doesn't support subscriptions. That's why I implemented a mock server using the Express framework in Node.js. The server is written in plain JavaScript and consists mainly of a single file, server.js. In addition to that, we also have a package.json file that stores information about all the required libraries at their versions. To make the server work, we need several libraries, including cores, Express, Express-GraphQL, GraphQL-WS, and WS. I've also created a start script to launch the server easily. To start the server, open your terminal and run npm install. This will install all the required dependencies. Then start the server using npm run start. This mock backend is a separate project, so it's best to run it in a separate editor window like Visual Studio Code or WebStorm, not in the same window where your Angular project is running. Once the server starts successfully, you'll see a message in the console showing the HTTP server address and the WebSocket address for subscriptions. Let's now take a quick look at the server.js file and walk through what's happening there. At the top of the server.js file, we import all the necessary libraries our server needs. Just below that, we create an object based on the event emitter class. This object allows us to send out real-time notifications via GraphQL subscriptions. Next, we define a variable called data that holds our mock data. Previously, these posts were stored in a separate file called db.js. Then we have the schema variable, which defines the GraphQL schema for our server. Here we declare types such as post, and we define a query called allPosts, which accepts page and per page arguments, just like we did earlier when using JSON GraphQL server. In addition to the query, we also define a mutation for creating new posts and a subscription called postAdded, which listens for new posts being added. The root object defines the resolvers, that is, how our server should respond to different GraphQL operations. It includes logic for the allPosts query, the createPost mutation, and the postAdded subscription. A quick note here. Even though allPosts accepts per page and page as arguments, the logic inside this mock server doesn't actually handle pagination. It just returns all posts. The goal was to make the mock server work without errors. especially when rendering the table rows and when adding new posts, just like it worked with JSON GraphQL-server. In the create post mutation, when a new post is added, we emit an event using the event emitter instance with an event name of new post. Thanks to this, the post added subscription listens for the new post event and can then notify the front end via WebSocket that something has happened. Below that, we configure the Express server. We use the CORS library to make sure our server accepts requests from any front-end domain. Then we configure the GraphQL server by providing the schema we defined earlier and the root object, which tells GraphQL how to handle each request. This server supports both HTTP requests for queries and mutations and WebSocket communication for real-time subscriptions. We've set the server to run on port 8080, which is the same port we used previously with JSON GraphQL server. Just a reminder, the WebSocket address looks slightly different from the HTTP address. Instead of HTTP, it starts with WS, followed by the host and port. The server also provides access to the GraphiQL tool, similar to what we had with JSON-GraphQL-server. However, this version of GraphiQL is older, so the user interface looks quite different. It's a bit more basic and less user-friendly. I've prepared an example mutation and query. Let's start by running the mutation. This mutation adds a new post with the title test. As a response, we receive the data of the newly created post, including its ID and title. Next, I'll comment out the mutation and run the all posts query instead. As we can see, the total number of posts is now 5, including the one we just added. Keep in mind though, since this is a mock server, all data is stored in memory. So if you restart the server, the newly added post will disappear, just like it did when we used JSON-GraphQL-server. Because subscriptions in GraphQL don't work over regular HTTP, but instead use WebSockets, we need to install an additional library that supports this protocol. To do that, open your terminal and type npm install GraphQL-ws. After installation, the library will be added to your package.json under the dependency section with the correct version number. Now we'll configure WebSocket support inside the graphql.module.ts file. Just a quick note, at this point in the course, I'm no longer using JSON GraphQL server. I've turned it off, and instead, I'm using the mock server running on port 8080 that I introduced in the previous lecture. Inside the Apollo configuration, we already use http-link.create to create a connection over HTTP. Let's extract it to a separate variable, for example, HTTP. This will be used for regular GraphQL operations like queries and mutations. Next, we need to create a link for WebSocket. We'll create a variable named WS, which will use the constructor of the GraphQL WS link object. As an argument, we pass the createClient function, and inside it, we pass a config object where we specify the URL. If we look at our current HTTP link, we're passing a URL from the environments file. I'll copy this line and paste it just below, but this time I'll rename API URL to WS URL. Also, I'll change the protocol from HTTP to WS. I copy the key WS URL and go to the environment.development.ts file. There I paste it in the same way so the variable is correctly picked up during development. Now back in graphql.module.ts, inside the createClient function, in the URL property, I pass environment.ws_URL. Next, we need to create a shared link for both HTTP and WebSocket. Here we use the split function, which lets us decide how to send data based on the type of operation. In split, we pass a callback function that gives us the query as an argument. Then we create a variable named definition, where we assign the result of calling the getMainDefinition function, passing in the query. Then we return a comparison using definition.kind and definition.operation. At the end, we pass two additional arguments, WS and HTTP, which are the links we created earlier. It means if the main definition of the query is an operation definition, and if this operation is a subscription, then we use the WebSocket link. Otherwise, we fall back to the HTTP link. Finally, we pass this link variable into the Apollo configuration inside ApolloLink.from. That link automatically picks either WebSocket or HTTP depending on the operation type. Now we're going to subscribe to the post added event. In app.component.ts, let's add a constructor where we'll use dependency injection. Private Apollo typed as Apollo. Next, we need to implement the onInit interface and create the ng-onInit method, which is a lifecycle hook. Inside ng-onInit, we use the Apollo service by calling this.apollo.subscribe. Inside the subscribe method, we pass a config object with the query key. For this, we use the GQL function, and inside the backtick string, we write the subscription. Start with the subscription keyword, followed by the name of the subscription. Let's call it post added. Then in curly braces, we specify the actual subscription name used on the server side, which is also post added. Inside that, in another set of curly braces, we define what should be returned by the server: ID, title, views, and comment. Now we need to subscribe to this observable since the subscribe method returns one. Inside the subscription callback, we'll do a console.log to display the full object returned from the backend. This way, we create a WebSocket subscription and can now listen for new posts as they are added in real time. Let's now check how it works in the application. Now, inside the application, let's add a new post using the form. Just remember that the table correctly displays the data, but pagination won't work. That's because we're using a different server than the one we used in previous sections. Here, we'll focus solely on the subscription. I'm adding a post with the title set to test. As we can see in the console, our console.log from the subscription appeared, which printed the data of the newly created post. That means the server correctly notified us about the creation of the new post. Now, to show that it also works when another client adds a post, let's switch to GraphiQL. Here, I've prepared a mutation that also adds a post, with the title set to test. I run the query and switch back to the application. Once again, we see a console.log that printed the new post. This means that we've successfully configured WebSocket communication, and we now have a live data stream from the server. This kind of setup would make it possible to build something, for example, like a chat application,